Hi students, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So yes everyone, how are you all? How are you all? So in today's class, we are going to do, let us see why I can see that search button over there. Yes. So in today, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry. I'm so sorry about it. Yeah. So in today's class, we are going to do thermodynamics. So guys, are you all ready for thermodynamics or not? And very good morning to everyone here. Very good morning to everyone here. Right? So I hope so you have also enrolled to your MVSAT, because most of the exams are actually done, right? So still this is actually the last chance. If you have still not enrolled into it, go and do it today itself, right now itself, right? Otherwise so you will miss the chance only, right? You know what all you are going to win here. Rewards you are going to win worth 1 crore, iPad, iPhones and all, and you're also going to have study material that is totally free of cost, plus Vedantu courses, whether it's online or it's offline. You're going to get it totally free of cost. Right, students? Okay, everybody in the chat box? Everybody in the chat box, is that clear? Yeah. So, let us firstly see the comments of students here. Pradeep, again, we done and dusted ionic equilibrium chapter. We are preparing good with the help of you teachers. Thank you so much, beta. Then Roshni, very good, answered it definitely correctly. Okay, then you have Sneha, ionic equilibrium done and dusted. Very good, beta. Madhumati, Navratri series day 9 done. Yes, equilibrium, chemical and ionic, both we have completed. Anuja, then you have DP Prasad, then you have Darshan. I'm not able to see the name because it's quite blurry, but thank you so much. And last is Tanuja with so many green hearts. So can I also see these green hearts in the chat box? Can I also see these green hearts in the chat box by the time? Wait a minute. Okay, so I hope so you have given me green hearts, because I'm just turning on the AC, right? You all know I'm in studio right now, and it's very different than my studio. So things get little complicated, that's why. Just give me a minute. Just give me a minute. Otherwise, your ma'am will die off with this heat. Hello. Sir, I'm not able to turn on the AC. I'm in the class. Can you please ask someone? AC on नहीं हो रहा, हाँ. ठीक है, okay. Okay, so yeah, I'm back. Okay, so yes guys, everybody in the chat box, let us start with today's class, that is your thermodynamics. Okay, so what do you mean by thermodynamics? Any idea? I know you'll be like, man, thermodynamics is very tough. You know, thermodynamics is tough until you don't know the sequence of how to study thermodynamics. Otherwise, it's a very simple chapter, right? It's just, you will be given some formula, you have to learn some formulas, and you need to know when to apply apply these formulas. For that, you need to know the basic terms of thermodynamics. So first thing, we are going to learn about the basic terms of thermodynamics, right? So thermodynamics, therm means heat, right? So basically here we are going to talk about dynamics, the changes in heat. I am changing the heat, right? Exchange of the heat, that is called thermodynamics. Dynamics means change, right? So when you are exchanging the heat, right, what are the different kind of things that can happen? We are going to talk about that in thermodynamics. So the definition is, thermodynamics is the study of heat and work, right? How it is dynamics, how it changes. It deals with energy transfer during chemical and physical changes. We will talk about mainly, so we will talk about physical changes only, right? And how we chemical changes only, and how we can predict whether the given change will occur or not will occur, right? So for that, there are some basic terms of thermodynamics that we need to study, right? Okay, so first is, what is universe, what is system, what is surrounding, and what is boundary, right? So these are very little things, and ma'am, weightage of this chapter, you can easily expect 3 to 4 questions from this chapter. 2 to 3, 3 to 4 questions definitely you can expect from this chapter, right? Okay, and most probably the question will be on the work, and for that you have to understand what is reversible, what is irreversible, what are the basic terms here. Only then you will be able to understand thermodynamics. So my request to you for thermodynamics is, if you really want to solve the questions, because it's not like they will ask you theory. They can ask you theory, but that will also be based on examples, right? For that also, what you need to do, firstly you need to understand the theory points, the definitions and the examples. From theory, they will directly ask you questions from the examples, and when we talk about numerical, for that also you need to understand the basic terms here, right? So let us see. First is universe. What is universe? Universe is, so before universe, I don't know what is happening here. Wait a minute. Okay. So for that also, firstly let us understand what is this system. System is anything that we are observing, that is under the observation. For example, I have a beaker. I am doing some reaction in that beaker. So now that beaker is my system. So system will be anything that is under the observation in which you are testing the heat changes, right? And what is surrounding? Surrounding is when you talk about universe, apart from, see, universe is everything, right? Universe is all the things in this universe is basically universe, right? So now, if I am saying that this is my universe, this is my universe, and universe is very big. This is my universe. And here, this is the system that I am working on. So now, all the other things except for that system is your surroundings. So basically, we can say that system plus surroundings, system that is under the observation, and other things, everything else in the universe except for the system is your surrounding, right? Now, our main task will be on the system, types of system, right? And what about boundary? Boundary is that thing which separates system and surroundings. The wall that separates system from the surrounding is called the boundary, right? Okay. Next thing is, what are types of system? As I told you, we are going to focus on the systems here. So what are the different types of system, right? So one is open, closed and isolated. For this, you have to, let's take an example of open, closed and isolated system, right? So when I talk about open system is where you will, for example, you have a hot tea, right? You have a hot tea. This is your cup and this is your fresh tea, right? This is your fresh tea. So what exactly is happening here? Can exchange matter as well as heat. So now it is able to exchange the heat, because we know that after some time that tea will get cooled or not. Or you will say, this is some other universe only, ma'am. Even if you have tea for 2-3 days, it will stay as it is, ma'am, that hot only. No, it's not possible, right? The tea will get cool, right? The reason is because it is going to exchange the heat energy, right, with the surroundings. That is why it will cool down. Second is, will it exchange matter? Yes, definitely it will exchange matter as well, because it is an open system, right? So it will have some exchange in the form of vaporization and different things going on at a very micro level. It will also exchange matter here, right? It will also exchange matter here. So that is your open system, which has both matter and heat energy is exchanged in this part. What about closed system? In closed system, for example, I have this cup of tea and I have kept one plate over it, right? So it is covered. Basically, it is covered. So because it is covered, when, for example, some of the particles will evaporate and they will collide with this upper wall, right? The walls of the container and this upper wall, but they will not be able to go out of this condition. Why? Because the system is not open. I have four walls here, right? I'm like, for example, in a jail, what you can do? In a jail, you can transfer what you are feeling, right, with the other person, right, who has come to visit you, but you cannot get yourself out of from that jail, right, directly, right? So that is not possible. This is like that jail, right? So here, definitely we know that after some time that hot tea will get cooled down or not. If you have closed container, that is closed, right, that is closed. You have some tea and you have kept a plate over there. But now after some time, you see this after 2 hours, will this get cooled down or not? Or will it stay as it is? It will not stay as it is. It will cool down, right? So here you see that there is exchange of heat energy, but there is no exchange of matter. Matter cannot be exchanged. So that is your closed system. Can exchange energy but not matter with surroundings. Any matter in a closed container, heating of water in a closed container, we observe these things daily, right? Next is your isolated system. So isolated system, you can talk about thermos bottle, right? So if you talk about thermos bottle, what you have, it is specially designed with the material, right? For example, I have this thermos bottle. My drawing is not very good, beta, but still I am trying. Learning from Gopika ma'am, right? So this is our thermos bottle. But here I am saying that it is closed, but the walls of this thermos bottle are made up of that kind of material where there is no exchange of heat, right? There is no exchange of heat at all in this material. There is no exchange of heat. The heat is as it is. That is why I am not saying any material in this earth is not 100% isolated. Right? It's not like you will keep the water bottle, you will keep the hot water in this thermos bottle, and after 3-4 days, yeah, it will not be cooled down, but the temperature will slightly get lower down. So in reality, in our world, in this true world, we don't have anything that is 100% isolated, that there will be no heat energy exchange, right? So in that thermos bottle also there is some amount of heat exchange, but that we can ignore totally. Still you can keep that bottle hot, that water hot for about 1 day, for about 8-9 hours, and that is sufficient for us, right? So that is why that comes under our isolated system, when there is no exchange of heat and no exchange of matter. Nothing is exchanged here, everything is as it is, it stays intact, okay? It stays intact. Right, students? Understood? Now, next is intensive and extensive properties, and mark this very important, because directly the question can be asked, and it has been asked, right? The question directly has been asked from intensive and extensive properties, especially the examples, right? Which of the following is intensive property? Which of the following is extensive property, right? Directly the question has been asked, okay? Yes, students? Yes? Okay. So, yes. Now, let us see this. intensive, you have to remember this by in. Okay, intensive, independent of mass. Intensive, how to remember, because students get confused in that. Ma'am, independent of mass, ma'am, dependent of mass, ma'am, I just, you know, I exchanged the definitions. I got confused in the exam. So how to remember this? Intensive is independent of mass, right? Intensive is independent of the mass and extensive is dependent on the mass. So all the properties that does not depend on the mass, that are your intensive properties. Intensive, independent, right? Now let us see the examples here. The examples as we have mentioned here: pressure, temperature. Acha, density mark it important here, right? I'll tell you why. Melting point for all the species. Okay, if you talk about the melting point of water, it will not change, right? The melting point, the boiling point of water, ice, all of these things will not change because you have taken more water, you have taken less water. It does not depend on the mass taken, it does not depend on the number of moles taken, right? So melting point, boiling point, temperature, pressure, EMF, refractive index, viscosity, surface tension, all these physical properties are intensive properties. It's very important examples, right? Then you have density. Now ma'am, what's so special about density? We will talk about that, right? Okay, just read with question mark here. I'll tell you why I have specially mentioned it here, right? Next is your specific and molar properties, right? This also we will talk once we have completed our extensive properties, right? Okay. Now ma'am, what is extensive property? Extensive property is dependent on the mass, right? So extensive properties are mass, right? That mass definitely depends on the mass, right? How much mass you have taken, that depends on the mass, right? So volume, that depends. Then your heat capacity, right? That also depends. I hope here I have not written volume, na, right? Yeah. So it was heat capacity. Now this is very important. Very important. Internal energy, Gibbs free energy, enthalpy, entropy. How to remember this? UGHS. UGHS. We will talk about what is internal energy in detail, what is Gibbs free energy, what is enthalpy, what is entropy. We will talk about all of these in detail. So you just have to remember UGHS. UGHS, that is your all the terms that we are going to discuss in detail in thermodynamics. They are your extensive property. They will depend on the mass that you have taken, right? Next is your this. So we have done volume and mass, and why. Now you will be able to understand why I have mentioned density here. See, when you divide two extensive property, the answer will be intensive property, right? When you divide two extensive property, the answer will be intensive property. As you can see here, density is equals to mass by volume. Mass is your extensive property, right? Mass is your extensive property. Can I write E here? Volume is also your extensive property, right? Can I write E here? So, I told you one property here, that the division of two extensive property will lead to the intensive property. So, this becomes your intensive property. That is why I have specially mentioned it here, right? That is why I have specially mentioned it here. Now, next is, ma'am, what about this specific and this molar? Why you have written it here? Because here also the questions are asked, right? Here also high probability the question can be asked from this only, right? So we know that I have specially mentioned here heat capacity. This also we will learn in detail, the definition, the numericals, the formulas, everything we will learn about heat capacity in today's lecture itself. Now heat capacity is represented by C, right? So heat capacity is basically, it is a extensive property. It will depend on the mass. We will get to know about in the definitions why it will depend upon the mass. But heat capacity will depend on the mass. But if I talk about molar or specific, always remember when something, if they have written specific heat capacity, that means they are talking about 1 kilogram. They have mentioned, they have fixed the mass here. So when you fix the mass, definitely it will not depend on the mass because mass is fixed here. Mass is not changing here. When mass is not changing, how can it depend on the mass? So heat capacity will depend on the mass, but specific heat capacity is independent of the mass because it is, I have fixed it for 1 kilogram. Now what is this molar property? For example, I am talking about any molar property. That means I am talking about 1 mole. That means I am talking about 1 mole. 1 mole means again I have fixed the 1 mole means the mass of that thing will be equals to the molar mass. 1 mole means, because what you know about molar, number of moles is equals to mass by molar mass. So when number of moles is equals to 1, when I am saying number of moles is equals to 1, then mass will be equals to molar mass. That means again I have fixed this. Again I have fixed the mass. So now again I have fixed the mass. That's why it is independent of the mass. So whenever, usually so they will ask you about specific heat capacity, molar heat capacity, you will say it is independent of the mass, right? Because we have fixed it. We have fixed for 1 kilogram for 1 mole. Understood this or not? Understood this or not, students? Understood this? Done, students attending here will go to school. This doubt for long time. Okay, please answer his doubt. Now, understood that, right? Okay, everybody? Yes, what is intensive, what is extensive property? Is there any confusion regarding that? If so, then write it down in the chat box. If there is any confusion related to extensive and intensive properties, because the question has been asked, okay? Okay. Next is state function and path function. Now let us discuss what is a state function and what is a path function. Okay. So now let us discuss what is a state function and what is a path function. Now let us see a state function, okay, a path function. By means only, by name only we can say path means it is dependent on the path. State means it is not dependent on the path, right? It is not dependent on the path. For example, you are, okay, for example, you are doing some work, right? You are going from, okay, for example, let us talk about strict parents and chill parents, right? Strict parents will care about the path, that if you have gone from school to home, right? So now they will ask you how much time you have taken, right? What was your path? Have you visited any of your friend? Have you gone out with any of your friend? Are you just, have you just come from school to house? Some parents are so strict, they will ask your teachers and call them, right? That okay, is my kid, was my kid there in the tuition? Was my kid there in the school? Right? And what's the time? They will calculate speed and time. They will calculate the distance. That how much time? How can you take 2 hours to reach your school from house? You are taking 2 hours, but actually it's just half an hour journey. Right? So they are strict parents. They will depend that what is the path that you have followed. But when I talk about chill parents, they don't care about the path. They're like, okay, you are home, you are safe, okay, we trust you, okay, fine. Right? So there are different categories of parents as well. So this is your strict and this is your chill parents, right? So they actually, property of system depends only on the path by which processes are done, right? And the examples are very important. See, we will talk about Q, that is your heat energy. We will talk about W, that is your work, right? Then we will talk about 4 properties, that is UGHS, right? What is the property? Now UGHS is your state function, right? They don't care. That is why whenever you are calculating delta U, you are calculating delta H, you are calculating delta G, you are calculating delta S. What matters is the initial and the final state. It doesn't matter what is the path. But when we talk about work, when we talk about the heat, we will talk about the path. We will talk about whether it's a reversible thing, whether it's an irreversible process, what is actually going on in there, right? So basically these will depend on the path that you have followed, right? So property of system depends only on the path by which process is being done. Right? Okay, always remember UGHS, that is your, that does chill parents, right? But your W and Q, they are strict parents, right? They will want to know where you are, like at this point, that point, they will want to know everything about you, right? Okay, understood? Yes, right? Okay, relatable, huh? Okay, so now let us talk about thermodynamics processes. This is where our whole chapter is going to revolve. We will talk about all the thermodynamics processes here, right? So, firstly, let us talk about isothermal. So, always remember what is iso. Iso means same, right? Therm means temperature. So, this means the temperature is same. The temperature is same here, right? It means the temperature is same. Okay, if you talk about isobaric, bar, what is the unit of which thing is bar? The unit of which thing is bar? Pressure is bar, right? Pressure is expressed in bars, right? So, can I say that here pressure will be same? Here pressure will be same. Isochoric, for choric means volume is same, right? Here you will say volume will be same. Volume will not change. Adiabatic, here heat energy will be same, right? There will be no exchange of heat energy over here. And what about cyclic process? Cyclic process is that process where you have a cycle, where there is formation of a loop, right? A loop formation, but in this case, the initial and the final step is going to be same. Initial and final position is going to be same. For example, I am saying that you have these two processes, right? You have this cyclic process and you have this cyclic process. Now tell me which of the following is cyclic process? A, B, C and D, and this is your A and this is your B. I'm marking it as A, I'm marking it as B. Usually students just cram the definition that okay ma'am, cyclic processes when initial and final points are same, right? But just see this here. It is forming a loop. For example, it has started from A position, A to B, B to C, C to D, then D to A. So it is forming a loop here. When there is formation of loop and the final and initial position same, then that is called cyclic. Here there is no loop formation. When there is no formation of loop, it is not cyclic. It is not cyclic in nature. This is definitely cyclic in nature. Okay, that is definitely cyclic in nature. Understood this point? Right? All the different things, have you understood or not? Yes, students, all the different things, have you understood that or not? Hanji. Yes, everybody? Yes, everybody? Okay. Acha. Now, let us see this thing here. That is internal energy, right? So before internal energy, let us see the graphs, isn't it? Let us see the graphs. I would like to tell you the graphs as well. So firstly, let us talk about internal energy, then we will discuss the graphs, right? So what is the internal energy? Let us discuss about internal energy. Let us discuss about heat. Let us discuss about work, right? These three things that will be useful in your first law of thermodynamics. Let us discuss about these three things here, right? And also internal energy, that is represented as delta U. Now tell me everybody in the chat box, is this a state function or this is the path function? I want to know that. If you remember, I want, you know, when you are studying things, right? If you recall it after 5 minutes, it will be there. You will be able to retrieve that, like after any time, after maybe 1 week, I'll ask you, you'll be like, yes ma'am, ask that question in the class. I remember that question. Why? Because that will be there in your head. That will get get its place in your head somewhere, that okay, ma'am can ask me anytime, I have to remember this thing, right? That's why I'm asking you here, right? Very good. It's a state function. Very good. Now, what is basically internal energy? Internal energy is sum of all the energies that are there in that system, right? Whether you talk about kinetic energy, potential energy, electronic energy, nuclear energy, any sort of energy that you talk about in that system. For example, I am the system. All the different types of energies that are present in my system together will form my internal energy that is there in your system, right? Now, energy stored within a substance is called internal energy. Internal energy of a system is equals to sum of all types of energy associated. Now, this is a very important point, that it is temperature dependent. It is temperature dependent. Now, very important thing I am going to write here. I know that for isothermal process, I know one thing, that your temperature is constant, right? Now, if your temperature is constant, internal energy depends on the temperature. Temperature is not changing, right? They are like best friends, best buddies. For example, your friend has told you, I will not come to school today. You will like, okay, you will not come, I will also not come. That's how it works, na? When your friend is not going to school, you are like, oh, what I will do in the school. Same is internal energy and temperature. They are best buddies. So, temperature is like, I will not change. Then internal energy is also like, I will also not change. So, here delta U is going to be 0. So, for isothermal processes, delta U is equals to 0. Wherever you will see isothermal, you will see delta U is equals to 0. Put it there, right? Okay. Now, very important thing, the absolute value. Have you ever seen U? No. We have always seen delta U, right? Because absolute value of internal energy cannot be calculated. We can only calculate the change in the internal energy. Absolute value of U can never be calculated. Only the change can be calculated. That is your U of final and initial. And why U of final and initial? Because it only depends on the state. It depends on the final and initial position. It is a state function. It does not depend on any it does not depend on any path here, right? It does not depend on any path here. Next is, when we are talking about U initial is more than U final, right? That means energy is decreasing here, right? So, extra energy is given out and delta U will be negative. Definitely, because you have final minus initial. If final is smaller than initial, then your delta U is going to be negative. Now, what does that mean? That means the system had some extra amount of energy. For example, you know some gossip about someone in your school or in your college or in your like locality. What you will do? That is the extra information that you have. You will try to give out that extra information, isn't it? Are you that person? I am to that person. Are you that person? Right? So, here the system is going to give out the extra energy, that information, extra information that the system has. It's like, okay, I'll give off the extra information and then I'll be happy. Right? Now, what about when your initial energy, initial internal energy is less? We know that it is final minus initial. Final is greater, so that means delta U is definitely going to be positive here. Right? Now, they are saying energy is absorbed, right? You are consuming the energy because earlier your energy was this. Now, your energy is this. That means you have consumed some amount of energy and you have jumped to that level, right? But here, initially what happened? Initially, the energy was high and the final energy was less. That means you have given out some energy here, right? You have given out some energy here, right? Internal energy depends on the temperature that I have already told you. Very, very important. Pressure, volume, quantity of nature. So, it is a state function, right? Next is, in most stable form, internal energy of the element is 0, and element in the most stable form in our universe is difficult, right? Everything has some amount of energy. Right? Everything has some amount of energy. Non-living being also, something is going. If you see that anything here, for example, I am talking about this phone, right? For example, I am talking about this phone. Now, you will be thinking that, ma'am, this phone is not moving. So, internal energy is 0. But there are there are atoms that are vibrating, some kind of energy is there in the system, right? So in our reality, having a system that is 100% unstable, that is 100% stable, not possible, right? So that delta U is equals to 0 is possible only when a system is purely stable. There is nothing going on in the system, but that is not possible in our reality, right? Okay, understood? Second is your heat and work. Second is your heat and work. Now let us discuss about heat and work. Okay, so heat is when you are giving the heat, right? Have you ever gone to kitchen, right? So what do you do when you want to boil something? You give it heat, right? You burn it and you give it heat, right? So that is your heat that you give, simple, right? So these are two ways by which a system can interact or can exchange energy with its surroundings. Now we are talking about that internal energy is being exchanged. Either the system will give out the energy or the system will absorb the energy, right? Two things can happen with internal energy. Now he is saying that there are two possible things in which these internal energies can change. First is your heat and second is your work. So now let us discuss about heat and work. This is heat, this is work, right? So now first is your heat, that is represented by Q. Heat is the mode of transfer of energy between a closed system. We are talking about a closed system here, and its surroundings during non-mechanical process where no mechanical work is going on. Right? For example, you are boiling the water, right? So what exactly you are doing? You are giving it heat and it is raising its temperature, right? And that is why, because internal energy is temperature dependent, that is why the internal energy will increase, right? So that is, you are exchanging the heat. You are from the surroundings, you are giving that heat to that system, right? Heat may be defined as the energy that is transferred from one body to another as a result of temperature difference. Have I told you this? Temperature difference. Before maybe the temperature was, maybe it was 5 degrees, right? You have given it heat. The temperature has increased to 7 degrees. Right? So there is temperature difference because of the heat energy that it has absorbed. Right? So when your temperature increases, that means heat energy is absorbed, isn't it? Can I write it here? Can I write this way? When your temperature, see, it's very simple. When you see this directly, you'll be like, oh, I have to cram this. But tell me, do you have to cram this? This is, in life you see this thing. When the temperature, whenever you give heat, right? Whenever you give heat, the heat is absorbed by the system. This is with respect to the system I am talking about. With respect to system, when the system is absorbing the heat, the temperature will increase. When the system is, for example, giving out the heat, right? The system is in we have kept something in our freezer. Okay, we have kept something in fridge, right? So what will happen? What will happen now? It will cool down because the system is giving out, it is releasing the energy to the surroundings so that the temperature can get lower, right? So here temperature will decrease because Q is being released, the heat energy is being released here, right? Heat energy is being released. Now let us talk about the sign conventions. Acha, tell me one thing. When you have to give something, for example, you have money, right? Money, right? For example, you have a lot of money. You have to give money. Will you be happy or not? Will you be happy? I too don't feel happy. Who feels happy by giving money? Who feels happy? Right? We don't feel happy because it's a very difficult thing to earn, right? So whenever you have to, for example, you have 100 rupees, right? And you have to give party or something, right? For example, you have 1000 rupees, right? And you have to give party to your friends. Then you will feel like, okay, I'm giving party, but I have to give my money. You will feel very sad, right? You will feel negative. So whenever heat is being released, heat is being given out by the system is not happy. System is like negative. I am very unhappy, right? So delta H, or you can say, here you can, Q will be your negative, right? Q will be negative here, right? Or we can also say delta H will be negative, right? Okay. Now, when Q is absorbed by the system is absorbing, somebody is giving you your mother, father, they are giving you, hey, take this 2000 rupees, that's your pocket money for this month. You'll dance like anything, you'll be like crazy, right? Gopika ma'am is like relatable topic, है ना? Gopika ma'am we can relate to this, right? So, when your parents will give you pocket money, 1000, 2000 rupees, you will dance like crazy. You will be like, oh my God, so rich I have become, right? So, you will be like very happy. Q will be positive. You will feel very, very happy after that. Go crazy, dancing, right? Okay. Bangalore days ma'am is talking about. That's true. That's why I'm talking about when money is given out. You never know that whenever I'm in Bangalore, I go bankrupt. Yeah, that's true. In Bangalore, it's so expensive to buy anything, to eat food, it's so expensive. Oof. So, now Gopika ma'am can totally relate because we have talked about this last evening only, right? So that's why I'm giving you this example. What is going on in my life, I will give you that example only, right? So this is beta, they are basically talking about the heat energy changes only, right? I've already told you heat is absorbed by the system, then it is positive sign. You are happy when someone gives you money. When someone takes money for you, that you will feel very, very sad. You will be very negative. You'll be like, oh, I have to give money again, right? Yes. Okay, so now there is thermodynamic work. So we can also relate to this one, है ना? We can also relate to this, Gopika ma'am. We can also relate to this. So now work is actually of many types. You have, Shreya sir must have told you. Shreya sir is always talking about work. Not only this work, but this work also. This is all in physics, right? Whether it's talk about gravitational work, you talk about electric work, you talk about mechanical work, all these work, Shreya sir has already taught you, right? But now let us talk about this work. Let us talk about this work that I need to relate. Right? So this is your expansion work or contraction work. So this work is basically, this is equals to minus pressure into delta V. Delta V is a change in the volume, right? So delta will become your change in volume, final volume minus initial volume, right? So that is your expansion work or compression work. So now let us see expansion and compression, what exactly is happening here, right? Okay. So, let us talk about expansion and, wait a minute, work done in compression or expansion. Yeah. Okay. So, now, my drawing is not so good, but still I'll try my best. Okay. So, now, let us see this. Let us see this. Now, you are doing the work on the system, right? You're doing the work on the system. Acha, tell me, have this ever happened to you? Are you the younger brother or the elder brother? Are you the younger brother or the elder brother? Tell me one thing. So, for example, what is happening? For example, someone is doing work for you. Someone, your younger brother, sister, right? They're always the target, right? Or your parents, anybody is doing your work, or your best friend, right? You have convinced them to do your work, right? So work is done on the system, right? They are doing work for you. Will you be happy or sad? Acha, tell me one thing. When work is done for you, work is done on the system. So the system will be happy or the system will be sad? The system will be happy or sad? Let me see. The system will be happy or sad? Younger brother, elder sister. Oh, very nice. Hanji. So tell me system, you guys are my systems. Okay, you guys are my system. Tell me, when the work is done on the system, system is like chilling there, relaxing, doing nothing. It's like standing there. I won't do anything. But someone else is doing work for them. They'll be like, oh my God, they are doing work for me. What I have to do? They are doing work for me. So the system will become very happy. So here, when the work is done on the system, right? When the work is done on the system will be like very, very happy, right? Very, very happy. The work will be positive here. The work will be positive. So someone else is doing work on the system. System is chilling and relaxing. Acha, tell me one thing. If the system has to do work, for example, now you're sitting there and you have to study. If someone else is studying for you, like they are reading day and night just for your convenience, and they will only give your exam. Oh, I should keep quiet now. Hai na? This actually happens. So I should keep quiet, right? So if system has to do work by its own, the work is done by the system. You have to do your work, right? Then what will happen? Right? Then what will happen? Right? Session, ma'am, session duration. But I never plan the durations, you know. I never ever plan the durations. My duration is I want to complete this chapter today. It's in 2 hours, 3 hours, 4 hours, doesn't matter. You have to complete the chapter with me today, right? If you really want to crack NEET, right? If you really want to be a doctor, right? You have to complete your syllabus on time. That is why I am very determined that I don't want to rush into things. I don't want to keep your syllabus hanging till Jan, Feb. No, I don't want to do that, right? So, how can we make both the things possible? That we also learn everything from the basic in detail, right? And also don't rush the things here, and also complete the syllabus on time. For that, you have to give your time to me, and for today, we have to complete this chapter. You have to promise me that, right? So now, if the system is doing the work is done by the system, then what will happen? Tell me. If work is done by the system will be very sad. The system will be like, oh, I have to do the work myself. I am not very happy in my life because I have to do the work myself, right? That's why the system will get very irritated, right? That why I have to always do this and that, right? So now the system is negative. Acha, sign conventions are very important. That's why I'm teaching you in a funny way. Acha, tell me one thing. When you are doing on the system, okay? If someone is doing work on the system, what will happen exactly? You are making it compress, right? Because you are doing work on the system. On the system, someone is doing work on the system. You're making it compress. So this is called compression. This is called compression. And when work is done by the system means the system will expand. I have to do the work. I will expand, right? So this is the system. It has to do the work. It will expand here, right? It will expand here, and here we are talking about expansion, right? And here we are talking about expansion. Is it clear or not? Right? Is it clear or not? What is compression? What is expansion? When sign convention is positive, when the sign convention is negative, is that clear to everybody out there or not? Right? Everybody out there. Is that clear? Now, is there any confusion regarding expansion and contraction? See, the work is done on the system, it is compressing. The work is positive, the system is very happy. Here work is done by the system is expanding, right? Here it is negative, and work is done by the system, it is expansion, okay? Is it clear to everybody? Okay. Right? Okay. Next is, this to beta we have already done, right? I have already taught you the sign conventions here, right? Now, let us see the graphs here, right? Let us see the graphs, and I know you will be able to answer this very easily. Now, first is your isothermal graphs. Now, isothermal graphs, I'll draw between P and V. Then I'll draw between T and V. Then I'll draw between, wait a minute, PV, TV, VT, PV, VT, PT, PV, VT, PV, VT, VT, PT, right? Now, tell me, for an isothermal thing, what will be the answer? Right? For that, you have to remember this equation, that is PV is equals nRT. number of moles and R is constant, I am saying, right? So in that way we can write PV is directly proportional to T. Okay? From this thing you have to answer all the graphs, right? Okay, so let us see. If we are saying that temperature is constant, so can I say that PV equals to constant? Because now not only N, not only R, but T is also constant. So PV becomes constant. So whenever PV becomes constant, can I say P is inversely proportional to V? P is inversely proportional to V, right? So that is why here the graph between P and V is going to be a straight line graph. Okay, it is going to be a straight line graph. That is for isothermal process, right? Wait a minute, not a straight line graph, because straight line graph is for y is equals to mx plus c, right? And this is clearly not the angle of y is equals to mx plus c. It will be like this kind of graph, right? It will be this kind of graph, right? So basically I have told you in the very first lecture where we talked about the basics of chemistry. I think I took that lecture around 3 months back, I guess, right? So there we talked about when x is inversely proportional to y, or x is inversely proportional to y square. In that case, this is the kind of graph that will be formed, right? This is the kind of graph that will be formed, right? Okay, now when temperature is constant, volume is definitely changing. So temperature will remain constant, right? But the volume is definitely changing. So can I say this is the kind of graph that will be formed, right? This is the kind of graph that will be formed here, right? That will be formed here. Acha, what about this? When your pressure is constant, when your temperature is constant, pressure is changing, then you will have this kind of graph. Isn't it? Isn't it, students? Is that clear or not? Acha. Next is graph of isobaric processes. So in this also I am drawing PV, then you have VT, then you have PT. You have to tell me the answer for these 3 kind of graphs, right? Again, from the ideal gas equation, can I say PV equals to nRT? Now pressure is constant, N is constant, R is constant. That means V is directly proportional to T. So when there is direct relation, then you will have a straight line graph, right? In this case, you will have a straight line graph that is not parallel to x-axis or y-axis, right? So here V is directly proportional to T. When two things are directly proportional to each other, the graph is like this. Okay, the straight line graph we draw. If they are inversely proportional to each other, then this kind of graph we draw. If they are inversely proportional, this is the graph that we draw. If they are directly proportional, this is the graph that we draw, right? Now, what about V and T? Now, volume, wait a minute. Here it will be, V is directly proportional, here it will be directly, yeah. Here though it is because pressure is constant. Pressure is constant and volume is changing, so it will be like this, right? It will be like this. Acha, what about this one? Here also the pressure is constant, temperature is changing, so it is direct. That should be a straight line, but yeah, now it's a better straight line, right? So this is also a straight line that is parallel to T. Right? Okay? Understood this or not? Understood the graph, students? It is very, very simple. Next is your, again I am drawing 3 graphs here. This is P and V. Another graph is V and T, and this is the third graph, that is your P and T. Now, from the ideal gas equation, it is PV equals to nRT. Now, for isochoric process, your volume is constant. This is constant, this is constant, this is constant. That means P is directly proportional to T. So, when P is directly proportional to T, that means this graph is going to have this straight line that is not parallel to any of the axes, right? When I'm talking about P and V, now volume is constant here. So volume will remain constant and the pressure will change, right? Here volume is constant, temperature is going to change. So volume is constant, temperature is going to change because at single volume you have different temperature values, right? So this becomes your graph for isochoric processes, right? Okay, okay. Ma'am, P is directly proportional to T, right? Yes, P is directly proportional to T. Very good, very good, very good. Shabash, very good. Now, this is the cyclic graph. This is important and this is the reason I taught you this whole graph thing, right? They will not ask you these simple graphs. Let me be very frank with you. If they ask you, they are asking you very simple things, right? So basically they will ask you these kind of things, right? They will ask you these kind of things, that are cyclic graphs, right? So in cyclic graphs, if I talk about P and V, right? I am talking about one cycle, that is I am talking about this thing here. I am talking about this thing here, right? I am saying that this is your A, B, C, D, cyclic processes there, A, B, C and D. Now, what they ask you in the question, where is the expansion happening, where is the contraction happening? This is what you have to tell, right? So, I am drawing the arrows here. The arrow is from A to B, B to C, C to D, D to E. It depends on the arrows. Now, this is a very important thing that I am going to discuss here, right? So, now let us see how we are going to discuss this. Before that, you have to know one thing about expansion and contraction. Whenever there is compression happening, the volume is decreasing, right? Volume is decreasing, compression, volume is decreasing, pressure is increasing, volume is decreasing, pressure is increasing. And in this case, when molecules are closer to each other, that means cooling is happening here. So that means cooling is happening. Right, so these three things are very important, very important. Now, let us talk about this. Expansion is happening. That means volume is definitely increasing, right? So, can I say volume is increasing? Pressure, the molecules are away from each other. So, the pressure is decreasing, the pressure has decreased. Now, whenever your expansion is happening, that means you are giving it temperature, you are heating it, that's why it is expanding, right? So here you can write that heating is happening in this site, right? Because they can ask you expansion or contraction. They can ask you whether there is cooling or heating. This is a very important concept, right? So now let us talk about this cyclic process and how to understand where there is cooling, where there is heating, right? So if you talk about AB, right? In AB, definitely what is happening? In AB, you have pressure is same, the volume is increasing, isn't it? The pressure is same, the volume is increasing. So when the volume is increasing, because it is going to this side, when the volume is increasing, what is happening? Expansion or contraction? The volume is increasing. Expansion is happening, right? So can I say expansion? This is a question of, I think, JEE. So this can be asked in your NEET. Directly the question can be asked, right? So this is volume is increasing, that means expansion is happening. So expansion means I am giving it heat, right? So heating. So here we are heating the system. If they ask you in terms of heating and cooling, you have to write this thing there, right? So then your B to C, what you can see? The volume is constant here. Volume is not changing, but the pressure is decreasing, right? The pressure is decreasing. So when the pressure is decreasing, that means the molecule, when volume increases or pressure decreases, this is nothing but expansion only. So can I say this is also expansion, and here we will say this is your heating, right? This is your heating, right? Very good. Now from C to D, C to D, pressure is constant. This is at one point only. But the volume is decreasing. So when the volume is decreasing, you are compressing it, right? The volume is decreasing, you are compressing it. Compressing it. Now C for compression, C for cooling, right? C for compression, C for cooling. I've also told you the logic behind that. If you don't remember this, then you can remember this by C for compression, C for cooling, right? So there will be cooling. There will be cooling. Okay. What about D to A? Beta, always remember this depends on the arrows. If I have exchanged the arrows, this will go opposite. If the arrow is from B to A, then this will become opposite. From B to A, volume is decreasing. Then that will be compression. So it depends on the arrows, right? You have to see the arrows as well, in which direction it is going, right? So here D to A, what you guys are saying, ma'am, it is compression, cooling, very good. So in this case, volume is constant, but the pressure is increasing. When the pressure is increasing, that means molecules are more closer to each other. Pressure is increasing. Pressure is increasing. That is your compression, compression. And here I can say cooling is happening. Cooling is happening, right? Okay. Cooling is happening, right? Okay. Understood this or not, everybody in the chat box? Everybody in the chat box, have you understood this concept or not? Chalo. Okay. Done? Done. Right. Now there is one more graphical question that can be asked, right? Yes, so it's a very old question, but still. For example, we know that for isothermal process, this was the case, right? For isothermal process, this was the case, right? This was the P and V. For adiabatic also, this is the graph. For adiabatic also, this is the graph. Now, if I mention this as 1 and this as 2, which is your isothermal, which is your adiabatic? Because the graph are same, right? So, first is your isothermal, first is your isothermal, first is your isothermal, and second is your adiabatic. Second is your adiabatic, and you can definitely write here that adiabatic process graph is steeper than the isothermal graph, right? Adiabatic is steeper than the isothermal graph. So this question can also be asked to you depending upon the graph. One more thing related to graph is that in a cyclic process, you can write it here, in a cyclic process, because in this loop, the final and initial positions are same, right? So you can write that all state functions will have values equals to 0. Why? Delta S, delta G, delta H, delta U, all of them will be equals to 0 because they don't depend on the path. Whether you are moving from this side to this side, you are going from this side to this side, you are going anywhere. If you are going from A and coming back to A, it doesn't matter what is the path. It will only depend on the state. So all the state functions will be equals to 0. In a cyclic process, right? In a cyclic process, all the state functions are going to be 0. Right, students? Understood this or not? Understood this or not? Right? Now, let us talk about reversible and irreversible processes. Acha, tell me how many of you know about reversible and irreversible processes and what you exactly know about them. Right? Let me see what you exactly know about them. What is a reversible process? What is an irreversible process? Because this is very useful in calculating the work, right? When you will calculate the work, especially they ask you questions on isothermal and adiabatic. In isothermal, there are two formulas. One is for reversible, one is for irreversible. In adiabatic also, there are two formulas. One is for reversible, one is for irreversible. Right? So, for that, you need to know the difference between reversible and irreversible. Right? Otherwise, though, you will not be able to understand. Right? Okay. So what is the reversible and irreversible difference? Let me see that in the chat box. Tell me what is the difference. What is the difference? Right? So I am not aware. No worries. You will be after 10-15 minutes. You will be pro in answering this. Right? So see, if you talk about a reversible process, in general term, the thing that can be reversed, I have taught you this in chemical equilibrium, that a reversible reaction is when it goes from A to B, it will come back to A, right? Only in reversible reactions there will be equilibrium, right? This also we have seen. But what is this definition when it comes to thermodynamics? This we have to expand our mind more, expand our horizons more and understand this, right? So now, let us talk about reversible and irreversible. Understand this thing. There is one student, right, who is just studying from like for just 1 month or 2 months for your NEET preparation, right? So he has taken this big thing in his head. He's like, okay, I will do all the preparation in the month of April, right? That person has thought that, okay, I'll do all the preparation in the month of April, right? So basically what is happening, there is this beaker, and you're applying the pressure here, okay? So this is your piston. I'll also make the piston here. I'll show all my talent today, right? So now this is the piston, right? This is the maximum amount of drawing that I can do, right? So you are decreasing, increasing the pressure, right? You are doing the compression. I am taking an example of compression here, right? So what you are doing, you are giving it pressure, right? So now the pressure is taken in just one thing. You are holding a big chunk of your syllabus and you want to complete it in just 1 month. In just 1 month you want to complete it. Now what will happen? You have this big mass, right? And by this big amount of mass, you are pressurizing it, right? By this big amount of mass, you are pressurizing it, right? Big amount of mass, you are pressurizing it. This is the student number 1, right? And this is your student number 2. This is your student number 2. This student number 2 has started the preparation with me, right? In the start of the, maybe, let us see, he has started the preparation in October with me, right? So they have started the preparation in October. So they are not like in one go, ma'am will teach everything. It's not like in just every single day I am taking the classes, I am completing like all the things in just 15 days. That I will do, but when the time is right, right? So, but right now I am taking the things really slow, right? So what I am doing today, right? I am going to teach everything. We have just read basics here, right? So this I won't be able to teach these amount of basics, like this much depth near your exam, like in April. I'll focus on questions more, right? I'll focus on PYQs more, right? So here what I am doing basically here, I am giving you little syllabus, little things, right? I am not pressurizing you with a lot of things. I am giving you little chapters, right? Every single week, 1 or 2 chapters we are studying, right? So it's not like a lot of syllabus, lot of pressure you have. It's like little things you are doing, right? So here also we are giving the pressure, but little, okay? Now, wait a minute. Now, what will happen? See, what is the condition of reversible? What is the condition of irreversible? Now, for example, this student failed. Okay? Now, you tell me one thing. Will this student be able to come back? Will this student be able to retrieve everything that he has studied in 1 month? Because everything has now, they have made a khichdi, right? Physics also, chemistry also, your bio also, you have done everything in just 1 month, right? You will forget everything within a month, right? It's like you will vomit out everything in the exam and then you won't be able to recall it again. When you are like, okay, now for the next year I will study with full dedication. But for that 1 month, you won't be able to come back to that. Why? Because with that, a lot of pressure, It is irreversible process. When you have a lot of pressure, right, a lot of pressure, you won't be able to recall everything that you have studied in 1 month or not. Is that practical or not? Tell me. Am I giving the relatable example? Can you relate with this thing? If you have studied anything, right, anything, for example, full NEET syllabus, you have never picked out any book for your NEET, you just want to study it for just 1 month, and now after you failed, and now you want to, with full dedication, you want to study, right? But for that 1 month, you won't be able to recall anything, right? So that is your irreversible process. So much pressure, that is why it will be irreversible process. Irreversible process. Just directly you give it one step, that is your irreversible process. And here, small, little steps you are taking. By chance, due to some condition, maybe your family situation, maybe your health situation, you are not able to crack NEET, right? Now, this has happened to so many students. They worked really hard, but somehow, maybe because of luck or anything, they were not able to crack NEET, right? It was maybe because that one day was not in their favor. Right? This happens, right? This is life, this happens. Now tell me, but this student is in more benefit. Why? Because this student has studied everything in detail. This student, if he is feeling that, he or she is feeling that I will drop 1 more year and I will prepare with full dedication, I will focus on what are the things that I did wrong. Now, this student, because he has made notes also, full lectures, he or she has watched, so everything is there. Also given mock tests, everything they have given. Now, they will focus on their mistakes. That means they can come back to their notes and they can see what are the things that I did wrong. They can work on those things. They don't have to start from the initial stage, right? So this is a reversible process. You can come back, focus on your mistakes and go back. You can come back, focus on your mistakes and go back. So this is your reversible process. Reversible process. I think this is, by this example, you will never ever forget in your life what is a reversible, what is irreversible, right? So in a irreversible process, you have big pressure in your head. So you won't be able to reverse back and see things. But when you are doing the things in small steps, then you will be able to reverse back. Now, very important thing, when we are deriving, okay, I'm not going to derive the formulas for you because derivations are not at all important for you. What is important to understand that when to apply which formula. So, for example, they have given us, for example, I'm writing it here. For example, they have given us just one step, that will be a irreversible process. And in this, you will not have any integration differentiation. But in reversible process, the formula will be of integration. Integration formula, right? Integration differentiation you will use because whenever we know in mathematics, you must have studied in physics, right? That integration is applied when you have small steps. Everything is changing in that small step. That is why you have dx. You integrate it. In small steps, you integrate it, then you get your answer. So that will be your reversible. For reversible, you will apply integration. For irreversible, you will not apply integration. Is that clear or not? Yes, student, is that clear or not? Right? Okay. So now I am going to write some of the things here for reversible and irreversible. Write some very important points. See, this is a one-step process, right? Just you give the pressure, it will just compress. So it is a one-step process. It is a one-step process. It is a multi. In small chunks, I am giving you the syllabus, right? So this is a multi-step. This is a multi-step process, right? Now, this is a very fast process. है ना? When we are doing the quick revisions, whenever we are doing the quick revisions, we are like tuck, right? So, we are very fast. But now, I am very slow right now. I am not running. I am just thinking that students should be able to understand everything, right? Because we have enough time. According to the time only I will teach, right? So here it is a slow process. It is a slow process. Now a very important thing. Wait a minute. Yeah. This is a very important thing that you will see in your question. At constant external pressure. This is a hint that you will get. Okay, this is a very, very important thing. Mark it. Very, 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 very important. DM important. Why I have marked it very, very important? Because see, in the question, either so they will give you directly that this is a irreversible process, right? Okay. Raining outside plus chemistry class is awesome. Yeah, the weather is really nice here. Really, really nice. I am totally loving the weather here. Totally loving the weather in Bangalore. So, this is at constant external pressure. When there is constant external pressure, when they have written that this is constant external pressure, then what you will say that this is a irreversible process. Right? In the question, you pick out any question, right? They will not directly give you this is an irreversible process. Rather, they will say that this is happening at constant external pressure. Whenever you see constant external pressure, you are like, okay, this is irreversible process. When they have written at variable, very, very important, at variable external pressure, very important, external pressure, then you will say this is a reversible process. It's a very important statement, right? So, for example, in the question, they will never, it's a very rare chance that they will give you it is a reversible process. Instead, they will give you that you will not see anywhere reversible. You will see at variable external pressure. है ना? The student who knows the difference, then when there is variable external pressure, then I'll say reversible. When there is constant external pressure, I'll say this is irreversible. Constant only, na? Because just one thing you are giving. So, this is a constant external pressure. Here you are variating the things, right? Here you are variating. Sometimes this, sometimes that. Sometimes I am teaching you chemical equilibrium, sometimes ionic equilibrium, right? Here I will teach you PYQs from full syllabus, right? Most important questions, right? Because we have to revise the thing in 1 month, right? Here we are picking out different things. Variable external pressure is there, right? Okay. Yes, in Bangalore also it's raining heavily from the past 2 days. Okay. Okay. Understood this, students? Any problem, everybody in the chat box. Everybody in the chat box. Any problem here? Any problem here? This is the crux, right, of everything. And this is a very important thing I am saying again and again. When you will do the numericals, you will remember me and you will say, thank you, ma'am. You made these numericals very simple for me. Right? Because this is where students get stuck. They don't know. In isothermal, there are 2 formulas of work. Students get stuck, ma'am, we are not able to understand which formula to apply. There is no reversible mentioned. So, which formula to apply? This will tell you which formula to apply. Right? Okay? Chalo. Now, processes other than reversible processes are known as irreversible, complete in finite time. All real processes are very, very important. All the real processes are irreversible processes, right? In our life, right, processes are usually irreversible processes, right? Okay. So, next is, first law is it? Yeah, it's a 0th law. So, now let us talk about the laws of thermodynamics. First is your 0th law. It's a very simple law. Never the question is asked from this law. Okay. So, we'll just go through this law. What is exactly this law? It states that if 2 systems are in the thermal equilibrium, if A and B, they are in the thermal equilibrium with each other, right? Then your third system, in thermal equilibrium with the third system, okay. They are saying that basically, if A and C are in thermal equilibrium, B and C are in thermal equilibrium, then B and A will also be in thermal equilibrium. This is basically that thing. If A is equals to B, B is equals to C, then C is also equals to A. Right? If I am your friend and you are a friend of Gopika ma'am, then me and Gopika ma'am are also friends. Right? Okay. So, A is equals to B, B is equals to C, and A is also equals to C. Very simple law. Never the question is asked from here. Right? So, basically they are saying that if A is in thermal equilibrium with B, A is in thermal equilibrium with C, then B and C are also in thermal equilibrium with each other. Right? Simple. Was this something they can ask you in NEET exam? No. They will ask you question from first law of thermodynamics. So let us see the first law of thermodynamics. First law of thermodynamics has different equation in physics and in chemistry, right? Because of in chemistry, we are focusing on the system, we are looking for the microscopic things. It's not like when you apply the same first law of thermodynamics, see, the sign conventions of work are different. I'll tell you very simple thing, right? It's a big war between physics and chemistry teachers that what exactly is right. So, even you're thinking that I will use physics, right? I will use the formula of physics. I will use the sign convention of physics. Then also you will get the same answer. If you use the sign convention of chemistry and you apply the formula for chemistry, then also you will get the same answer. The answer will be same. It's just that the perspective of physics and chemistry teachers was different. Not teachers, the scientist was different, right? So here, let us see first law of thermodynamics. It's basically that your delta U, internal energy, is equals to Q plus W. This is your first law of thermodynamics. The energy can neither be created nor be destroyed, right? However, may be transferred from one form to another. This you have been studying this, like I don't know, from 6th or 7th class you have been studying this. The energy can neither be created nor be destroyed. It is only converted from one state to other state, other type of energy. So it's the same thing they have written here, that internal energy basically is equals to Q plus W, the work that you have done, the heat energy that they have exchanged, right? Okay. So now, next is this, so I have already told you what is, okay. Now, let us see the question here, okay? Let us see the question here. This is your 2008 question. Let us see who all of you are able to answer this. Which of the following is a state function? I'm not able to see this. Which of the following is a state function, right? Which of the following is the state function? Now, tell me which of the following is a state function. First is your Q plus W, right? Achha, tell me one thing. What is Q plus W? Q plus W is nothing but it is delta U, right? Q plus W is nothing but it is delta U. Then you have Q, you have W, you have H minus T delta S, right? You have H minus T delta S, that is equals to G. I'll tell you, this is the equation, delta G is equals to H minus T delta S, right? So, this is equals to G. Now, can I say that this Q and W, which of the following are not state functions, right? So, which of the following are path function, basically they are asking us. Which of the following are path function? So, path function, which depends on the path, that is your Q and W. Rest of them do not depend on the path, right? So, Q and W depend, that means second and third, right? So, second and third will depend on the path, that is Q and W, right? Internal energy, delta G, delta H, delta S, they all does not depend on the path. They are the state functions. So, answer will be A will be your correct answer, is it? Very good, shabash, very good. A becomes your correct answer, right? Next is your isothermal processes for first law. Now, I am going to define this. You don't have to cram this thing. I'll just apply the first law for different processes, okay? I'll just apply the first law for different processes, okay? For different processes, I'll simply apply the first law. So, let us see. Tell me one thing, if you talk about an isothermal process, if I talk about an isothermal process, can I say that temperature is constant? And when we were talking about isothermal process, I told you that internal energy is dependent on the temperature. They are best buddies. If your temperature is constant, then internal energy will be like, oh, you are not going to school, I will also not go to school. So, internal energy will also be 0. That is, it is also constant. Final and initial internal energy will be same. So, delta U is equals to 0. Now, what is your first law of thermodynamics? That is, delta U is equals to Q plus W. Now, this becomes 0. So, it will be Q is equals to minus W, or you can say W is equals to minus Q. W is equals to minus Q. Right, so this they have given. Heat energy given to the system under isothermal condition is used in work. Heat energy that is given in this, given by the system, right, that is given to the system is used in work done by the system, right, is used to against the external surroundings, right. If work is done by the system and you are giving out, so can I say that here basically they are saying that minus W is equals to Q, right. So heat energy is given to the system, that means the system is absorbing the heat energy, that's why it's positive, and here work is done by the system, right, that's why it is negative, right. Understood why they have, why this is important, why this by the system and heat energy given is important. For example, if you are giving the heat energy, if this is positive, say simple thing you need to apply here, if this is positive, then this will be your negative. If this is negative, this will be positive, right, because they are opposite to each other in sign, right. So if heat energy is absorbed, then system is doing the work, work is done by the system. If heat energy is getting, if it is system is giving the heat energy, that work done will be on the system because work is positive then. Understood? Yes? Yes, students? Okay, students? Okay, everybody in the chat box. Now, second is when you have adiabatic. So tell me in the chat box what was an adiabatic process? Adiabatic. What was the adiabatic process? Everybody in the chat box. Yes, what was the adiabatic process? When there is no heat energy. There is no heat energy change. So Q is equals to 0 here. And we know that your first law of thermodynamics is delta U equals to Q plus W. Right? So Q is 0 here. Q is 0. Do you have to remember this? Tell me. Do you have to remember this? You just have to know the definition. Students are like, oh, I'll cram everything, ma'am. In the book, everything written, I'll cram everything. You need to do cramming. I know that there are some formulas that you need to cram, but do where it is needed. Here it is not needed, right? So it is delta U equals to W. So the same thing is written here. Work done on the system brings increase in the internal energy. Because if I am saying increase, that means delta U, I am saying it's positive. If work done on the system, that means work is also positive. If work is positive, delta U is positive, right? So work done on the system will increase the internal energy, right? So that's why I'm saying that you don't need to cram these statements, but they can ask you these statements in the exam. Then you will get confused. Then ma'am, I don't remember on, by, you don't have to remember that. You just have to remember that in adiabatic process, Q is equals to 0. This will be the formula. Based on this formula, you can easily say that which statement is correct. Right? You can easily tell that which statement is correct. Isn't it? Adiabatic, no change in heat. Very good. Very good, very good. Very good, Tanuja. Now, next is your isochoric process. Now, what is an isochoric process, everybody? What is an isochoric process? Where delta V is equals to 0, there is no change in the volume. And we know that work is equals to minus P delta V. If delta V is equals to 0, then work is also 0. Now, from the first law of thermodynamics, can I say delta U equals to Q plus W? Now, work is 0 here, right? I can say that work is 0, right? Work is 0. So, delta U will be equals to Q. Now, this is a very, very important thing that I am writing here, right? So, here it is at constant volume. So, from here, this is a very, very important thing that your QV, what is QV? Everybody, what is QV? Heat energy change at constant volume is equals to internal energy, and this is a very important formula, right? That heat energy exchange at constant volume is equals to internal energy, right? Okay, that also we have derived as in fun we have derived this, right? So funny, ma'am, right? So here, can I write here, this work is actually the work of adiabatic, isn't it? So here I can write work of adiabatic is equals to internal energy. Work of adiabatic is equals to internal energy, right? Okay. Now, here I am writing internal energy is equals to QV. So now, heat given to the system, given means absorbed by the system. Heat is given to the system under constant volume is increases internal energy, right? So now, can I say that if this is positive, that means heat is absorbed by the system or heat is given to the system. Any statement can be written there, right? So, this is also positive. As we can see, there is no negative. There is one negative here. Then we can see the sign is opposite. This is also positive. Delta U is positive when internal energy is increases, right? So here, if heat energy at constant volume is positive, that is absorbed by the system or given to the system, basically pocket money. Parents are giving you. Either you can say pocket money given by the parents, or you can say pocket money given to me, right? So, it's the same thing, right? So, under constant volume increases the internal energies, right? Next is very, 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 very important, right? That is your isobaric process. In isobaric process, you have, see, in isobaric process, you have like P is equals to constant, pressure is constant. So, can I say that your delta U, I can also write it. I want to derive it myself, right? So, I will write it here. Delta U equals to QP, because at constant pressure, plus work done. Now, work done is nothing but it is equals to minus P delta V, minus P delta V. So, can I write here, this is, I want to find out the value for QP. So, QP I can write QP equals to delta U plus P delta V, right, plus P delta V. So, delta U is nothing but U2 minus U1. This is plus P V2 minus P V1, right, because delta V is U2, V2 minus V1, right. So, you just add the 2 here, that is U2 plus P V2. This is minus of U1 plus P V1, right, U2 plus P V2, right. Now, we will study this when we will study enthalpy, when we will study H, right. So, U plus PV is equals to H, right. So, U plus PV is equals to H, that is your enthalpy, right. We will study this when we will study in detail the enthalpy, okay. You need to have some patience for that, okay. Okay. Okay, students, why are you deleting the messages? I am not your that strict teacher, okay, that you need to delete your messages here. So, U2 plus PV2, that is your H2, this is minus H1, right, and this is your QP. So, can I say QP equals to delta H? So, this becomes really, really, really important, right, mark it very, very important. So, your QP is equals to delta H, that is your enthalpy change. Your QV is equals to delta U, that is your internal energy change. Is that clear? Because we are going to use these two formulas a lot. We are going to use this as well. We are going to use this as well. We are going to use this as well. They both are very, very important, right? Okay, students? Yes, students, is that clear to everybody here? Is that clear to everybody here? Right? So now let us do the cramming part. Okay? I'll write down some formulas of work here. So everybody till now, any problem? All the students who are present here, tell me, is there any problem till now? Any problem till now? Apart, we will study about the work done in isothermal process, right? Then adiabatic. Adiabatic, so we will study. Firstly, we will study enthalpy, heat capacity. Then we will study adiabatic, right? But adiabatic we will study in the end. Before that, we will study. Before the break, we will study all the other work except for adiabatic work. Okay? Ma'am, isobaric, please explain it again. Okay. So in isobaric, you know this definition of work. We know that work is equals to delta U is equals to Q plus W. For adiabatic, this is not adiabatic, for isobaric, isobaric only you are saying, na? Isobaric you are saying, na? For adiabatic, isobaric, right? So, for isobaric, this is that constant pressure, so that is why Q I have written by QP, right? This is minus P delta V. What is work? That is P delta V, right? So I have written, I just want to calculate the value of QP from here. So I'll just, QP is equals to delta U plus P delta V, simple maths, right? So now what is delta U? That is U2 minus U1, final minus initial. So final minus initial plus, what is this delta V? That is final minus initial. So P into V2 minus P into V1, right? So then I will add U2 and PV2. It becomes this minus of U1 and plus P minus. You will say, ma'am, why this is minus, this is plus? Because overall I have taken the bracket here, right? So here it will be, what is this? This I will tell you when we will do enthalpy, that your enthalpy is equals to U plus PV. Right, so H is equals to U plus PV. So I have applied it H2 minus H1, that is QP. So QP will become equals to delta H. Okay, QP will become equals to delta H. Is that clear to everybody here? Is that clear to everybody here or not? Everybody in the chat box. Everybody in the chat box, is that clear or not? Is that clear or not? Is that clear? Yes, bachcho. Yes, bachcho. Acha, now what is this? This is the cyclic process. Let us see the cyclic process. We know that for the cyclic process, initial and final state are same. So all the state functions are same. Have I told you that, beta, everything is interconnected with each other in thermodynamics, right? So we know in cyclic process, all state functions are equals to 0. And when you apply this in delta U is equals to Q plus W, this is not a state function, this is not a state function, but this is the state function, that becomes equals to 0. So Q will become equals to minus of W, and hence you will write, one of the implications of this result in cyclic processes is that the amount of heat absorbed, if I am saying this is your positive, right, by the system absorbed, that is positive, then this will be if this is positive, right, then this will turn out to be negative here, right? Negative work is done by the system, right? So from the surrounding is equal to the work done by the system, right? Understood? When I am saying here amount of work heat absorbed, when this is positive, definitely, because if this becomes positive, this will be negative, right? Because Q is equals to minus of W, right? That means W is equals to minus of Q. If your Q is, let's say, minus, Q is equals to positive, that is 5, then W will become minus 5, that means W will become negative here, right? So in negative means the work is done by the system, right? The work will done by the system, right? Okay. Okay. But for cyclic processes, I told you all the things in cyclic processes. Initial state is equals to final state, right? You have to be 100% attentive here, okay? You have to be 100% attentive, right? That's not good that you are not 100% attentive. I told you, everything is interrelated to each other. Everything. Cyclic processes, I have told you in detail that all the cyclic processes, the state function are 0. Now you don't know state function are U, G, Hs. Internal energy, enthalpy, Gibbs free enthalpy, Gibbs free energy and entropy. All will become equals to 0. But in first law, I just need delta U. So if delta U is equals to 0, Q is equals to minus W. Right? Okay? Okay, so everything is interrelated to each other in this chapter. One point you are like, okay, thinking about this and that, you will lose the hold of the full chapter, right? So that's why be very attentive, very attentive here. Now, here it is. 2002 question. In a closed insulated container, a liquid is stirred with a paddle to increase the temperature with of the following statement is true. Closed insulated. Now if you talk about closed insulated only you can say that Q is equals to 0. Right. So if Q is equals to 0, here Q is 0, here Q is not 0, so this cannot be the answer. Q is not 0, this cannot be the answer, this cannot be the answer. So answer to we already know it is this. But still I'll try to find out the other thing. So delta U is nothing but delta E. In question, in some books they represent delta U by delta E. Right. So don't get confused in that. So delta E is equals to W plus Q. Delta U is nothing but it is just the representation is different in some books. Abhi in today's, because it is 2002 question, right? Back then it was represented by delta E, but now in most of the things you will see even in the exam it is represented by delta U only, right? So if this becomes, if I am saying that this is equals to 0, then delta E is equals to W. So it is there, right? That is not equals to 0. So answer becomes A is the correct answer, is it? A becomes the correct answer. Yes, 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 everybody. Okay. Now it's the tough part that has started. The tough part has started. So how you're liking the chapter? Are you able to understand? Everybody in the chat box, are you able to understand the things here? Are you able to, feel this chapter? Are you able to understand what exactly I am talking about? Because in the next stage of this chapter, this is going to be a little more concepts will be there, right? So more formulas will be there. But I am telling you, if till now you are able to understand everything, if your base is clear, students what they do now, they never, they don't see the base. They will say first law is equals to delta U is equals to Q plus W. Now let us see the work formulas. Now I have taken 2 hours to explain you the basics. Now I know that the next things are going to be so simple for you. You'll be like, okay ma'am, this is so very simple. I don't know why I was feeling that this is so complicated. Now this will become actually very simple for you. Okay? Yes. Formulas. Now formulas, I know it's a little cramming is there. I know even I hate cramming. You know how much I hate cramming. But that I can't do anything. No, I can't give you a slip that okay, you can cheat in the exam. You don't need to cram. You have to, right? But I'll try my best that you don't have to cram so much, right? So there is some logic behind everything so that you're able to understand that, right? So now, first is work done in a reversible isothermal process. So understand one thing, when you talk about a isothermal process, there are basically 2 things that you need to understand here, right? So there is one for reversible and one for irreversible. One is for reversible, other is for irreversible, right? You have 2 things here. So we'll talk about reversible and irreversible both. So firstly, I will talk about irreversible process. Let me talk about irreversible process first, right? Because that is simple, right? So now we will calculate the work here. I am not going to talk about anything else except for work, right? All we are going to talk about here is work because we are doing the work and this is also doing the work, right? Let's appreciate the work done by all the processes. So first is your irreversible isothermal process. Acha, everybody in the chat box, spam it in the chat box. Irreversible. Is it a big syllabus or when you are doing little chapters daily, right? Is it that student who is doing syllabus in the month of April or that student who has started the preparation in the month of September or say August? Which is that student? Irreversible process. What is that student? Is it doing the work in one single step or is it doing the work in multiple steps? Let me see. Irreversible, shabash. Everybody in the chat box. Irreversible. Is it a multi-step thing or it is a one-step thing? Is it a multi-step thing or is it a one-step thing? Where are you guys? Thinking about multi-step, one step. Is it April? Right? April. Irreversible means April. Very good, April student. No, not September. Single step. It is like, okay, I want to study everything in just one go. Right? It's that student who have not studied anything. Right? That is why the student will not be able to recall anything. That is why it is an irreversible process. So it's the April student, right? So it's a big syllabus is there, right? Big syllabus is there. So it has to complete everything in one go, right? So that means one step, right? It is a one step. So whenever you have one step, there will be no integration. No integration. So simply what you will do here, you will say that your W is equals to minus P external delta V. Is it? Right. So now tell me minus P external, what is delta V? That is V2 minus V1. Can I write delta V is that is V final minus initial. That means V2 minus V1. Right. Now from the ideal gas equation, I am writing it here. From the ideal gas equation, can I say that PV equals to nRT? Right? N is same, R is same. This has changed, this has changed, this has changed. So V1 is equals to nRT1 by P1. And V2 is equals to nRT2 by P2. Right? From the ideal gas equation. Can I just put these values here simple? So it will be minus P external. Now tell me external pressure will be constant here, right? The external pressure is a big syllabus. So that is constant. That is not going to change. I am not going to teach every single day all the different concepts in detail. No, that's not possible in the month of April, right? Okay, in the month of April, that's not practical, right? So, this is minus P external, V2 minus V1. So, what is V2? This is nRT2 by P2 minus nRT1 by P1, right? So, this becomes your formula, right? This becomes your formula. Wait a minute, this is isothermal, na? So, why I have written T2? This will not be T1, T2, right? Because T is also constant, no? T is also constant. So, it will be this, right? It will be this. So, you will write it as nRT by P1 minus nRT by P2, right? So, you can take that common. So, it will be minus P external nRT 1 by P1 minus 1 by P2, right? 1 by P1 minus 1 by P2, that is the formula of your work when you are saying that it is in the irreversible process, right? When it is doing the syllabus in the month of April, just one part it is doing, right? Okay, and when did you get sight? I always had eyesight problem, right? I was just ignoring that. But now I cannot ignore that. Okay. So now this is W is equals to minus P external nRT 1 by P1 minus 1 by P2. Is that clear? Is that clear? 1 by P2 minus P1. Wait a minute. This will be 1 by P2 because this is V2 na. So this is P2 minus P1 and this is your P2 minus this is your P1. Okay. So this becomes your answer for the work done in the isothermal irreversible process. Is there any confusion regarding this? Is there any confusion regarding this? Any confusion? So can I proceed with the next, that is your isothermal for reversible process, right? Isothermal for reversible process, right? Can I say okay. Now, let us talk about reversible process. Now, tell me, is that in multi-step or is this one step? Small parts I am giving you. Chemical equilibrium done. Ionic equilibrium done. Thermodynamics done. Then we will do electrochemistry. Then we will do redox reactions we have already done. Right? Then chemical kinetics. Then solutions. Right? So, everything we are doing very slowly and in detail. Right? So, that is multi-step. right? So we are doing things in multi-step. Multi-step means small steps we are using. Small steps we are using. So in small step, when you are doing the things, there will be integration, right? So let us see what is the formula, that is W is equals to minus P external dV. Now here I have written delta V because there was large syllabus. Delta is for large change. When the change is big, that is delta, right? But when I talk about D, that is a small change, right? When there is change, small change, very small changes there, right? So this is dV, right? Now I told you here you have variable external pressure, right? I am changing the syllabus daily. Today I am teaching you a thermodynamics, right? So I am daily changing it, right? Please teach integration and explain. I'll ask Shreyas sir to do that. Okay. So I'll teach whenever it is there in your derivations. I'll teach that. Okay. Okay. What is needed for chemistry, I will teach you that. Right. Otherwise, in physics, you have it in detail. Now, W is equals to minus P external dV. Right. So this dV, I am saying that there is variable external pressure. So, because of that small external pressure, it is approximately equal to internal only. So, we take the assumption that this external pressure is equals to P internal dV, right? So, now here I am using the rough page. In the rough page, I know that you have PV equals to nRT. Can I say that P is equals to nRT by V, right? I'll just put the value of P over here, because if I want to integrate, I need the value of P in terms of volume. Only then I will be able to do the integration here, right? So here, if you don't want to know the derivation, it's okay. If you want to know the derivation, just go through this only derivation I am teaching you, because it is important, right? So here it is minus NR. Here it is minus NR T divided by V, it is dV, right? This is your W, this is your W. Now, I need to integrate it. So, I will integrate it on both the sides. Integration is when you have small steps, then only you can integrate it, right? Now, next is for integration, I will take the term that is constant outside the integration. So, N is constant, R is constant, T is constant, minus is constant. So, it is nRT. This is integration 1 by V dV. Okay. This is, this after integration, it will become W only. Right? It will become W only. Now, if I have to solve this, now what is 1 by X dV? This is nothing but natural log of V. Okay. The answer for the integration of this is natural log, ln V. Okay, that is the answer for this thing, right? That is the answer for this thing. So here I will write W is equals to minus nRT. Integration is a very vast topic. You don't have to go through in detail of integration, because I am a non-medical student, right? I have studied maths in my BSc as well, in my 11th, 12th as well. Integration is a very big topic, right? You don't have to understand everything about integration, right? Just understand in the derivation how it is used, right? So here it is 1 by V dV, that is natural log of V. Now I am saying it is going from V1 to V2, from initial to final. So my initial is V1, final is V2. Initial is V1, final is V2. Right? And here it is from 0 to W. That is why it becomes W only. Now here it will become minus nRT natural log of V2 minus natural log of V1. Right? And we know that the definition of, by the definition of log, if I want to, by the definition of log, natural log of or any log of A minus log of B, that will be equals to natural log of V2 by V1. Right? If you don't want to do the derivation, it's totally fine. Right? It's totally fine. You're like, ma'am, I don't want to do the derivation. Just give me the formula. I'm giving you the formula in the end. Right? Just remember that this formula you will apply for reversible processes. Right? When there is multiple step, when the pressure is variable. Right? Okay. So now here it is V2 minus V1. Now we don't know the value of natural log, so it will be like minus 2.303 nRT because we have to convert it into log base 10 V2 by V1, right? Log base 10 V2 by V1. Okay, students, understood this? Yes. Now this is the main important formula. I just shown you how this was, like, why we have done this for a reversible process. You don't want to do the derivation, just completely skip it, right? But just remember that for multiple step there is integration. After integration only I have calculated this formula, right? Now if volume is given to you, this will be the formula. If pressure is given to you, you will apply this formula, that is minus 2. My 2 is such a unique, like 2.303 nRT natural log of, it's P1 by P2. Now it will go reverse because pressure and volume are inversely proportional, right? Because nRT is, we know that pressure and volume are inversely proportional. If it is V2 by V1, now it will become P1 by P2. Now this is important, right? This is important. This is your final formula. This is very, very important. Right, this is very, very important. This is the formula for reversible isothermal process, and that is the formula for irreversible isothermal process. And definitely in your PYQs also you will see a lot of question based on these. Mark it DM important. Very, 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 very important. Right, students? Okay, that is a very, very, very important question, right? Okay. Yes, everybody in the chat box. Everybody in the chat box. Is that clear? Is that clear? Is that clear? Right? Is that clear? Okay. So now let us do the work done for isobaric. The isobaric is simple. Isochoric is very simple. Right? Only difficult. Two works are difficult. One is your isothermal. Next is your adiabatic. Right? For adiabatic, so we have to understand a lot of things. But for adiabatic, I will not teach you any derivation, because derivation for this is a very easy derivation, right? But for adiabatic, it's a long derivation, right? So it also involves other things. So that's why I'll give you directly the formula that you have to apply. And in adiabatic also, simple direct questions are asked based on the formula. You just need to understand which formula to apply. Okay. So is there any problem in isothermal processes? That is clear. Yes, students, V1, V2, lower limit. Yes. Very good. Okay, ma'am. Questions on this? Yes, I'll show you the questions also. Right. Now, yes, ma'am. Okay, perfect. Now, next is your, what is this? Isobaric process. For isobaric process, what you have to write? See, for isobaric process, we know that pressure is equals to constant and work is equals to minus P delta V. So this will become your work. There is no change, right? This will become your work. Work is equals to minus P V2 minus V1. This will become your work. Simple. Okay. No tension. That's why they will never ask you. I'll tell you, na, they will ask you from isothermal or they will ask you from adiabatic. If they are asking the work, they will ask isothermal reversible, isothermal irreversible, adiabatic reversible, adiabatic irreversible. Rest of them are very simple, right? So they will not ask you, right? Okay. What about isochoric? Now we know that here V is equals to constant, right? So delta V is equals to 0 because there is no change in volume, right? So V2 minus V1 is equals to going to be 0, right? So here work done is equals to minus P delta V. If my delta V is equals to 0, then my work will also be equals to 0. So for isochoric process, the work done is equals to 0, right? So for isochoric process, the work done is equals to 0. Yes, very good, very good, very good. So work done is equals to 0, right? Okay. 3 processes we have done: isothermal, isobaric, isochoric. Isothermal we have done in detail. Rest of this is very simple, right? Adiabatic we are going to do after we study about heat capacity and all of that, right? Now cyclic, you know what? The difficult part we have already done. We just one difficult part is left, that is your adiabatic work. Rest of it is very simple yet very important. Entropy, Gibbs free enthalpy, very important, right? So here we are talking about cyclic processes. So let us see cyclic processes. Let us talk about cyclic processes here. So if we are talking about the cyclic processes, they are asking you to calculate the work done here. Then how you will calculate the work done here, right? If they are asking you to calculate the work done, this is A, right? So this is A, B. Anybody in the chat box? A, B, C, D. Any cyclic process they tell you, they ask you the work done. So work done is equals to, work done in a cyclic process is equals to area enclosed. Area enclosed, right? The area that is enclosed here, that will be your work done, right? That will be your work done. Okay, students? So this is the area, right? So the area that is enclosed here, that is your work done, right? This will become your work done, right? Okay. So next is when it will be positive, when it will be negative. If for example it is going from A to B, B to C, C to D, D to A. So now it is going in a clockwise direction. So whenever it is going in a clockwise direction, work is equals to negative. Now if it is going in an anti-clockwise direction is this direction. If it is going in this direction, this is anti-clockwise direction, right? Clock moves like this, now the opposite direction is anti-clockwise. So anti-clockwise direction. In physics I know it is opposite, but here it is, the sign convention is this only, right? So according to the sign convention this happens. In physics this is opposite, so don't get confused in physics and chemistry, right? Don't get confused in that. Okay. Now next is your open vessel. If you have open vessel, then what will happen? Acha, in the open vessel, everybody in the chat box, in the open vessel, what will happen? So work done is equals to minus P external delta V, right? We know that from the ideal gas equation. We know one thing, that from the ideal gas equation, your PV equals to nRT. So if I am saying that your P delta V I want to calculate, that will be nR delta T, right? So I can put the value as delta NGRT. Yeah. You can put the value because there will be change in the gaseous moles, right? So you can put it as minus delta NGRT, right? If temperature is given to you, right? So that will be delta NGRT. And this is also important, but it is not asked so much, but you need to understand that you can put it like delta NG, right? Delta NG. Okay. Delta Ng is what? Delta Ng, if they ask you what is delta Ng, it is number of gaseous moles of product minus reactant. So for example, we are talking about NH3 give rise to N2 plus H2, right? So here it is 2. Here it will be 3, right? So what is gaseous moles of products minus reactants, or on the gaseous phase? So it will be 4 minus 2, that is delta Ng is going to be 2, right? Delta Ng here is going to be 4 minus 2, that is 2, that is positive. So if your delta Ng is positive, work is positive, work is also positive. No. If delta Ng is positive, work is negative. So work will be done by the system or on the system. They can give you any reaction. They can ask you that calculate whether the work is done by the system, whether the work is done on the system, right? So when you are given any reaction and they are asking you work is done on the system or by the system, it means they are asking from this particular equation, right? It means they are asking this thing. You have to calculate delta Ng. If that is positive, this will become negative. The work will be negative. That means the work is done by the system. Work is done by the system. Understood this or not? Everybody understood this? When the work is done by the system, right? If your delta Ng is negative, right? If I talk about the reverse of this reaction, opposite, delta Ng is negative, then work will be positive. If work is positive, work is done on the system, right? Okay, understood? Any problem here? Any problem here? Now let us see this thing. Let us see this question. It is given to be X moles of ideal gas at 27 degree expands isothermally and reversibly. So reversibly means you are going to apply natural log formula, right? And here they have given you the volume. So V2 minus V1. So it will be natural log of 10y divided by y. So natural log of 10 you will have, right? Natural log of 10 you will have. And N is given to be X. Temperature is given to be 300. R is this. So I think this will be the correct answer. Answer will be this. The correct answer will be C will be the correct answer, isn't it? Which formula we have applied? W is equals to minus 2.303. We cannot write because it's a natural log. So it is minus nRT natural log of V2 by V1, right? So number of moles is X. R is given to us as it is. Temperature is 27, that is 300 Kelvin. V2 by V1 is given to us, right? Is it right? Okay. So answer will be C is your correct answer. Okay. Now next question is 2017 question it is. A gas is allowed to expand. Now this is a very important question. Okay. These kind of questions are asked usually, right? So let us see. Right? Now here you will be able to understand how to apply the concept that I have taught you. A gas is allowed to expand in a well insulated container. Okay, in a well insulated container against a constant external pressure. Now beta, tell me one thing. Tell me one thing. Against a constant external pressure, right? Constant external pressure, is this reversible or is this irreversible, right? Is this reversible or is this irreversible? Everybody in the chat box. Constant, that means big syllabus I am giving you, right? That one big mass I am giving you, right? So that April student, right? So this is basically your irreversible process they are talking about. Irreversible process. Okay, from here you got to know that this is a irreversible process, right? And a constant external pressure is given to be this from initial volume to final volume. This is your V1 and this is your final volume, that is V2. That is V2. The change in internal energy in joules will be, see, work done is equals to this is your Q plus delta U. Now my Q is equals to 0. So work done is equals to delta U. So that means they are asking you work only, right? They are asking you work only here. So work is what? Work is for irreversible process. What was the formula? For not reversible, for irreversible process, there is no integration, nothing is there. So answer will be that was your minus nRT. Its volume is given, right? So volume is given. So in terms of volume, so you don't have to do anything. Volume is so very simple. So this is your minus P external delta V. So what is your minus P external is given to be 2.5. So this is minus 2.5. What is V2? V2 is given to be 4.5 minus 2.5, that is your initial volume, right? So this becomes minus 2.5 multiplied by 2, right? So that will become minus 5. Here let us see, is this in joules, right? Yes. Okay. So this will become, wait a minute, minus 2.5 P external, right? We have to multiply this, right? We have to multiply this with 1 point something, right? 1 point something, only then you will get the answer in joules, right? Only then you will get the answer. Otherwise here you are getting the answer is liter atmospheric, This is liter, this is atmospheric. You are getting the answer in liter atmospheric. So you have to convert it into joules, right? So this becomes your minus 506, right? So answer will be minus 506.6. You have to convert it into joules, right? It will be in liter atmospheric, right? The answer will be in liter atmospheric. You have to convert it into joules, right, student? So, okay. Okay. Okay, everybody. Now, yeah. So, you have to multiply this with 1.1 into 3. Right? This you don't have to remember. Just remember 1.1 into 101.3. When you multiply this with that, then your liter atmospheric is converted to joules. Right? Okay, then your liter atmospheric is converted to joules. Right? Okay. Okay, students. Now, we will take break. After break, we are going to do enthalpy. We are going to do heat capacity, Poisson's ratio, degree of freedom. Then we will do adiabatic process work, how to calculate the final temperature. Usually in adiabatic, they ask you calculate the final temperature, right? So, which formula to use in reversible and irreversible process. After that, entropy work, we will be finished by that. Entropy in different processes, theory question based on entropy, Gibbs free energy, Gibbs Helmholtz equation, and last but not the least, there will be Hess's law and your thermochemistry, right? So in thermochemistry, usually 2-3 kind of questions are asked, right? That will be product minus reactant or reactant minus product. Students usually get confused in that. Bond energy will be there, heat of formation will be there. So we will talk about all of those things, right? Okay, students? Yes? Thermochemistry, ma'am. Yes. Thermochemistry is also simple. Don't worry about that. Right? Okay? So, I'm going to give you break now. Ma'am, your voice is echoing or not? Is it my voice is echoing? Is it? If that is so, I'll ask the team about it. Tell me, is everyone facing the same issue? Finally got answer. Yes. Because I was busy in that thing, no? Yeah. Okay, guys. So, now let us have break for how much time? Let us have break for 15 minutes. Okay? Let us have break for 15 minutes. I'll see you, I'll see you at 12:40 or maybe, right? I'll see you at after 15 minutes. Or I'll write 12:40, I'll see you. Right? Let's complete this chapter today itself. Okay? So, Okay, students, so I am back. Everybody in the chat box, are you there? Everybody in the chat box. Am I visible? Am I audible to everybody? If yes, then green hearts in the chat box if I am visible and audible to all of you. Yes, Dinesh, Tanuja, Sneha, aesthetic, evening star, aesthetic, huh? So aesthetic you guys are. So, okay, I am visible and audible. Okay, perfect. So now let us start the session. Hello, Roshni, everybody. Let us start it. Right now, echoing ma'am. Okay, let me ask the team then. Just give me a minute, okay? Let me ask the team. Okay guys, so I have asked the team will be here in some minutes, right? By the time you have to adjust, right? Okay, so I clearly don't know what is the issue that is happening here, okay? Is it like echoing now only or it was echoing when I started the class? At 10 a.m. itself, was it echoing back then also? Yes, everybody in the chat box, yes. Chalo, let us start the session now. Let us talk about the enthalpies, okay? Let us talk about what is delta H. Now, what is this delta H, right? Enthalpy. Enthalpy is basically the heat energy that is absorbed. It will tell us whether the heat energy is released or absorbed, right? It is related to heat only. The amount of heat energy that is absorbed by the system or the amount of heat energy that is released by the system. Right. So, when you talk about the exothermic class, right, for exothermic we can say that if it is negative, heat energy is being released, then we will say delta H is equals to negative heat energy is released by the system. For an endothermic process, we say that heat energy is absorbed by the system. That is why delta H will be positive, right? That is why delta H will be positive this side, right? Then next is your this thing. Now here you can write that delta H equals to H2 minus H1, right? Now, you remember when we were calculating it for isobaric process, I told you one thing, that H is equals to U plus PV. Right, H is equals to U plus PV and the absolute value has no as such significance here. That is why let us calculate. For example, I am saying H1 is equals to U1 plus P1 V1. Right, here I am saying H2 equals to U2 plus P2 V2 plus P2 V2. Now I am subtracting these two terms. So H2 minus H1, that is your delta H will be equals to a very important equation that I am deriving here. H2 minus H1. This H2 is U2 plus P2 V2 minus P1, and now this is minus H1. What is H1? That is U1 plus P1 V1. Right? So this becomes your equation. Now, can I say U2 plus P2 V2 minus U1 minus P1 V1? Right? So this U2, U2. Let us see, I want to combine the internal energy here. Right? So that will be U2 minus U1 plus this will be P2 V2 minus P1 V1. Can I say that? Right? So this U2 minus U1 will be nothing but that is your delta U plus this is your delta PV. Now you will be like, ma'am, no, pressure should be outside the bracket, ma'am. That's why I have given you this equation so that there is no confusion left, right? So I'm going to derive 2-3 equations here, right? So now see this thing. See this thing, I'm going to write it here. I have written delta H is equals to delta U plus delta PV. I have not mentioned that pressure is constant or your volume is constant, right? Ma'am, lag echoing, it's start before the break. Students, just give me some time because I have no idea why this is happening, right? Only the team can answer that why this is happening. Now is it better? Now? Is it better now? Yes, students, is it better now? Let me see what exactly is there. Hello, hello. At box, yes. Hello. P is basically. Okay, that's too much echoing. Hello. It's still echoing, right? Don't know what is the issue. Students are saying, yeah. Yeah, I have called the team again. Just wait a minute, okay? Just wait a minute, okay? Yes? Go. Yeah, I have called Mithun. Mithun was there in the meeting, so he is coming. Change the mic, ma'am. Students, I have just this mic. Now, our IT team is here. So please tell us that how to resolve this. Students are saying a lot of, even I have observed that a lot of echo is there.
Okay. Now is the echo fine?
Don't tell me that was the issue.
Yeah,
But in the middle of the class it started.
in the middle of the class, I think ये off था because of some key might be start.
Now students, tell me, is there any echo now? It's not that bad also, ma'am. It's echoing slightly. Okay, ma'am. Now is it better?
And it's because of
Okay.
now.
No, I think so. It's better now. Let me see.
बच्चे बता दो. Oh, it's English channel.
Yeah, it's English channel.
I can speak in Hindi then.
No, they understand. Chill. Don't worry.
Is it
They're very
fine?
smart.
Oh yeah, yeah. Nowadays children are very smart.
Very smart. So I think, oh my god. Still echoing.
No, now check. अभी बताओ.
Ma'am, still echoing. It's fine, I guess.
Let me check.
Slightly.
बच्चे झूठ नहीं बोलने का. Let me check.
Yes, ma'am, it's fine, ma'am. When is your yesterday class, ma'am? Gopika, ma'am, where is your yesterday? It will be soon, don't worry. Yes, Gopika, ma'am, please guide me. Is this better? It went for London.
What?
It's fine only.
Yeah, it's fine.
It's fine, no?
Yeah.
Okay. So, guys, blue hearts for Mithun. Blue hearts for Mithun, sir. He has resolved it. Chalo. Everybody thanks him, okay? Bye bye. Chalo. Okay, it's perfect now. So, shall we resume the class? Right? Okay. Shall we resume the class, guys? Everybody in the chat box? It's fine, ma'am. Perfect, perfect, perfect. So, everybody fill the chat box with green hearts, right? So that we can complete this session today itself, right? In detail, we will solve the numericals also with that same energy in your chat box, okay? Now, I told you about this enthalpy change, that is delta H is equals to delta U plus delta PV. Now students will be like, ma'am, why you have written PV in terms of delta? Because I have not written whether pressure is constant or volume is constant. If I write at constant pressure, then I will say delta H is equals to delta U plus P I will take out, this is your delta V. Because now the pressure is not changing. If I say that this is at constant volume, in that case delta H is equals to delta U plus, now that constant term, that is your volume, that will be taken out. This is your delta P, isn't it? This is your delta P, right? Yes. Perfect, perfect, perfect. Now, let us see. Yes, beta, it is enough for JEE Mains as well. Just go through the PYQs, right? Okay. Now, delta H is equals to delta U plus V delta P. Usually, you will see this in your books, right? Because we assume that the pressure is always constant only. Because in work also, pressure is constant. That is why usually you will see this thing only, right? Now, if you have to, see, in the question, if they are giving you pressure, they are giving you volume, there is no reaction given to you. In that case, you will use any one of these. These two equations you can use, right? If there is no reaction given to you, but if some reaction is given to you, then the things will change. Here you will substitute PV is equals to nRT, right? PV is equals to nRT from ideal gas equation, right? So here you will say that delta H equals to delta U plus delta NGRT. Now, this is the equation that you will use when some chemical reaction is given. Some chemical reaction is given. And in that chemical reaction, you will have to find out the value of delta Ng, that will be number of gaseous moles of products minus gaseous moles of reactants. This R is your gas constant and T is your temperature in Kelvin, right? Okay, so you will just put the formula, just put the values here. Delta U will be given to you in the question, right? Okay, just remember, two formulas we have. If some chemical equation is given to you, you will use this formula. If no chemical equation is given to you, they have given you pressure or volume, then you will use that formula, right? Okay, yes. Yes, students, everybody in the chat box, is that clear? Right? Now, this we have done already, right? This also we have done already. Now, next is your heat capacity. Now, heat capacity is when you want to raise the temperature to 1 degree. You just want to raise the temperature, 1 degree difference should be there. For example, earlier it was 45 degrees Celsius. I want to raise the temperature to 46 degrees Celsius. So that means I am raising the temperature by 1 degree. Now the heat that is involved here, that will be your heat capacity. Right, that is going to be your heat capacity. So the definition is heat required to raise the temperature
by 1 degree Celsius is called your heat capacity. And there are different types of heat capacities. Very simple way we will learn this. Heat capacity represented by C is equals to heat involved in raising the temperature by 1 degree. So whatever temperature change is there, right? So that will be over here. So the C is equals to Q by delta T, right? This is from the definition. If this is 1 degree, then definitely heat capacity is nothing but heat that is to raise the temperature by 1 degree Celsius, right? Okay. Now, next is we are talking about heat capacity at constant pressure and constant volume. So, let me draw this line in between, right? So, here I am writing about Cp and here I am writing Cv. What is Cp? What is Cv? Cp is nothing but this is heat capacity at your constant pressure. So that is Q will become Qp and this will stay delta T. This Cv, this will become Qv, this will stay delta T. Now tell me one thing. Qp. Have we derived it? Clear, Chintu ma'am? Very good. Have we derived it before? What is your Qp? That is equals to delta H, isn't it? Do you remember that? We have derived it. Cp is equals to delta H by delta T, right? So mark it important, right? I know you will be like, ma'am, no ma'am, there is N also want. Wait. Okay, wait. Have patience. That's why I'm clearing your concepts here, right? In NCERT, some of the things are mentioned, but in the bracket, they have mentioned that, right? That is, I'm clearing out some things here. So this Qv is equals to nothing but delta U. This is delta U, this is delta T. Now remember one thing here. This Cp is for N moles. This Cp is for N moles. This Cv is for N moles. I am not deriving it for 1 mole. Right? I am not deriving for 1 mole. I am writing it for N moles. For N moles, this is a formula. If there are N moles, any N moles is given to you, then the formula will be delta H by delta T, delta U by delta T. That is the formula, right? But if they ask you specific heat capacity, molar heat capacity, so let us talk about the molar heat capacity. Molar heat capacity is for 1 mole. That means what you will do here? You will divide it by 1. Isn't it? You will divide it by 1, right? So what you will do here, everybody in the chat box, what you will do here, that will be divided by 1. Right, divided by N. So if I say my Cp is equals to delta H by delta T, then my CPM, M is for molar heat capacity. CPM will become equal to delta H by N delta T. That is for 1 mole. If my Cv equals to delta U by delta T, then my CVM will become equals to delta U divided by N delta T. Now, write it here. This is for 1 mole. This is for 1 mole. This is for N moles. This is for N moles. This is for N mole. N mole. This is for 1 mole. This is for 1 mole. Right? This is for 1 mole. Right? So, you must have, seen this, that I'm going to write one formula here that you will use, right? The direct question can be asked. From this, can I say that delta H equals to N CPM delta T? Okay, and here delta U equals to, very important, NCVM delta T. Now understand one thing here, right? This is your, in books what it is written, in books it is written as NCP delta T, right? So students, in the bracket it is written that that is for 1 mole, right? So that's why I'm saying that learn it by this method, right? Instead of learning the directly formula from the books, right? So this is your CPM. We know that this M means for molar. Okay? So this is your NCVM delta T. These two are very, very important formulas. Tell me, is that clear or not? Are these formulas clear or not? Right? Now, what was specific? What do you mean by specific heat capacity? Anybody in the chat box? What do you mean by specific heat capacity? Right? When you're talking about substance by 1 unit mass, and I am taking that unit mass as kilograms, right? Okay. So that is CPS, specific. So that will be delta H divided by delta T, but that will be divided by the mass of the substance, right? If I am saying 50 grams, so that will be divided by 50 here, right? CVS is equals to delta U divided by mass into delta T, right? Specific is not used that much, but yes, the other one is used, right? Specific is used less, but you never know what they will use in the exam, right? So we don't want to take any risk here, right? Okay, so heat capacities that are clear to everybody here, right? Everybody here, that is clear now. At constant volume, right? QV is equals to CV delta T and QP is equals to CP delta T, right? Okay, we have done this already. Now let us talk about Poisson's ratio, right? What is this Poisson's ratio? Poisson's ratio says that CV divided by CP, that is equals to gamma, right? That will be equals to gamma. Adiabatic index, heat capacity, what it is, gamma is called adiabatic index, heat capacity ratio, adiabatic exponent and isentropic exponent. So any of the name can be asked. Name they rarely ask you, right? But they will ask you the formula of that gamma. Gamma is equals to CP by CV, right? Gamma is equals to CP by CV. Now, next thing is your this formula that says that CP minus CV is equals to R, right? And this is for 1 mole, right? Okay, usually the formula is CPM minus CVM is equals to R, or you can say CP minus CV is equals to NR. So basically here they are talking about for 1 mole. They are talking about molar capacities here, right? But in the NCERT you will see this only. In the NCERT you will see this thing only, that is CP minus CV. But in the bracket they must have written that this is for 1 mole, right? So this is CPM minus CVM is equals to R, CP minus CV is equals to NR, right? Okay, understood? Now, you can, one more formula you can write in terms of degree of freedom, right? These are all the formulas, right? So, CV is equals to R by gamma minus 1 and CP is equals to gamma R by gamma minus 1. No derivation, nothing is important. Just remember these formulas as it is. One more formula in terms of degree of freedom, because I want you to learn that with the help of degree of freedom, right? That will become easy for you. Now, CV is equals to FR by 2, where this R is your degree, where this R is gas constant, F is your degree of freedom. Now we know that CP you will calculate by CP minus CV is equals to this, so CP will calculate by R plus CV, right? This you can calculate from this side, right? Okay. Okay students, understood this or not? Everybody in the chat box, is that clear or not to everyone? Yes, student, is that clear not for everyone? Right? Ma'am, why is CP value greater than CV value? Because of this formula itself, right? We will calculate CP value, why it is greater, we will see with the help of degree of freedoms, we will calculate, right? Okay. Tell me, is there any problem? This is very important. The students get confused in this, right? So this is very important thing. In NCERT it is mentioned like this, but they have written for, in the bracket you will see they have written for 1 mole, right? So students usually skip what is written in the bracket. They will like, okay, CP minus CV is equals to R. No, CPM, molar heat capacity minus molar heat capacity at constant volume is equals to R. When you talk about n number of moles, then CP minus CV is equals to NR. This is for n number of moles. This is for n moles. This is for 1 mole. This is for 1 mole. That's what I am saying again and again, that in your book it is written Cp minus Cv is equals to R. But in the bracket they have mentioned for 1 mole. Students usually skip this and then they learn Cp minus Cv is equals to R. But that is not the correct formula. The correct formula is Cp minus Cv is equals to Nr. That is for n moles. But if you talk about 1 mole, we are talking about molar heat capacity. So Cpm minus Cvm is equals to R. Is that clear to everybody? Is that clear to everybody? This is very, very important. Tell me, is that clear to everybody or not? Right? Are these two equations clear to you? Right? Okay. Now, next formula is to calculate Cp and Cv with the help of degree of freedom. Right? So, Cv is equals to Fr by 2. This formula you don't have to derive. You can just learn it as it is. For example, they have given you the value of gamma. Right? So, you can calculate the value of Cv from there. They have given the value of gamma. You can calculate the value of Cp from there. Right? So, just mug up the these two formulas here. That's it. Okay? Students, tell me, is that clear or not? What do I have to repeat here? I don't understand. What do I have to repeat here? This is your Cp by Cv is equals to gamma. That is the Poisson's ratio, right? I have not derived it, right? So, scientists told us that this is the ratio. Cp minus Cv is equals to gamma. So, related to gamma, the next formula is Cp minus Cv is equals to R. But I am saying don't remember this thing. Don't remember this thing. Instead, remember this thing. Cpm minus Cvm equals to R. Right? And Cp minus Cv is equals to Nr. You just have to remember these two formulas. That's it. Right? I am saying that is written in your NCERT. I am saying the same thing. I don't know what different I will say in the next class. In the next take, what I'll different I'll say. So, this is Cp minus Cv is equals to R. It is there in your NCERT, but in the bracket they have mentioned for one mole mole. For 1 mole they have written. But bracket students usually miss that. They cram this formula. That is why I am saying remember these two things. You don't have to remember bracket for 1 mole anything. No. Cpm minus Cvm is equals to our molar heat capacity. But if you are not talking about molar heat capacity, that is Cp minus Cv is equals to Nr. Okay. This is so simple. Na? This N, if you take this N over here, this is Cp by N minus Cv by N is equals to R. What is this Cp by N? This is nothing but Cpm minus Cvm is equals to R. Okay. So, that is the same thing that I have written there. And these are the two formulas directly. You just have to remember this. Now, we are going to focus on these two things. Cv is equals to Fr by 2 and we will calculate Cp after that. Right? Okay. Okay. Okay, everybody. Chal. Now, let us see. Don't get scared of this. This is actually very simple. Right? So, I'll just give you a simple version of this. Right? You don't have to cram this. Just remember 2-3 things. Right? For monatomic gas, the degree of freedom is 3. For diatomic or polyatomic linear, degree of freedom is equals to 5. And here the degree of freedom is 6. Now, ma'am, how? For monatomic gas, when you have only one gas, only one atom, it can do translation motion on 3 sides. Basically, degree of freedom, we talk about translation, we talk about vibrational, we talk about rotation motion. Right? Okay. But while calculating degree of freedom, we only calculate the rotation and the translation. Translation is when I am moving like this in my x-axis or y-axis, when I am just simply as a moving. Right? That is my translation motion. Rotation is, for example, I started to rotate like this. Okay. So, when I start to rotate like this, that is my rotational motion. Right? Vibration is, for example, I am like totally going mental like this. Right? So, that is my vibration. I am sitting there, but I am vibrating. So, vibrational we don't take in degree of freedom. We take, here we take translation and rotation. Is that clear to everybody? We take translation and rotation, right? Okay. Okay, students. So when you talk about translational, monatomic gas does not show any rotation. If you have one monatomic gas, it is rotating, right? So I had molecules at my home, but not here. So it is rotating. You have any ball that is rotating. You won't be able to tell whether it is in some different direction, right? So if you have any basketball or anything, it is rotating, it is spinning on its own axis. There is no difference that it is going to make. So that is why there is only 3 translational motion that you will have. That is your F is equals to 3. We're talking about diatomic gas. This is your diatomic gas, right? So in diatomic gas, it can have 3 translational. That means it can go to this side, to that side, to that side. So X, Y and Z direction, 3 translation can be there. What about rotation? It can rotate like this, it can rotate like this, it can rotate like this, or it can rotate like this, or it can rotate like this, right? It can rotate like this. So basically there are 2 rotational motion here, right? So that is why 3 plus 2 is equals to 5. Right? So I can even write it here, 3 plus 2, F is equals to 3 plus 2 equals to 5. This is same with your linear polyatomic, right? If you have 3, like carbon dioxide, it is polyatomic, it has 3 atoms, 1 carbon and 2 oxygen, right? It is your C double bond O, C double bond O. It is like this only, linear only. So it will also do 3 translational and 1 your this rotation, other is your maybe this kind of rotation, right? This kind of rotation it can do, this kind of rotation, right? Now what about non-linear polyatomic? Again translational will be 3 plus there will be 3 non-linear means, for example, I have this thing, wait a minute, for example, this is my non-linear. Now you can see that this is not a linear thing, right? This is a linear thing, this is not a linear, right? So it can rotate in 3 forms, right? It can do rotation like this, it can do, wait a minute, it can do rotation like this, okay? It can do rotation like this. Now because they are not joined, that's why they are, you know, getting little bit scattered here and there. It can do rotation like this, right? This kind of rotation can be there, right? Now, what's the second kind of rotation? It can do rotation like this, it can do rotation like this, right? It can do rotation like this, it can do rotation like this, that these molecules themselves can rotate, right? This kind of rotation. One is the molecule is completely moving like this, other is the molecule is completely, like not completely moving, just like this, this kind of rotation. For example, you have 2 bonds, they are rotating like this, right? They are moving like this. So this is the third kind of rotation that is additionally added, right? So total it has 3 rotations, so it will become 6 degree of freedom, right? Understood? So it will form 6 degree. If you are not able to understand that in 3D, it's okay. Just remember for monatomic it's 3, for diatomic or linear polyatomic you will have 5, right? For diatomic linear, any gas you talk about, H2, O2, N2, any gas. Linear polyatomic means like carbon dioxide. Non-linear polyatomic means like SO2, right? What about this monatomic, like helium, neon, all these are monatomic, right? So if they give you any gas in the question, you have to firstly identify what kind of gas it is, then you know the degree of freedoms, right? Then what you will do, you will just apply this formula that CV equals to FR by 2. Right? So here degree of freedom is 3, so it is 3R by 2. Degree of freedom is 5, so it is 5R by 2. Degree of freedom is 6, so it is 6R by 2, that becomes 3R. Okay? That becomes 3R. Now, we will calculate the value of Cp from there. Cp is equals to Cv plus R. So, 3 by 2R plus R, that becomes 5 by 2R. Take the LCM. This will be divided by 2, 3 plus 2R, that becomes 5R. This is your 5 by 2R plus R. That becomes 5, 6, 7, 7 by 2R. This is 3R plus R. This becomes your 4R. So that is your Cp. Now what was the value of gamma? Gamma was Cp by Cv, right? So Cp by Cv, Cp will become 5. What is Cp? 5 by 2R. Cv is 3 by 2R. So they will cancel out each other. The answer will be 5 by 3. The answer will be 5 by 3, that is 1.66. This is a very important thing, okay? Very important table we are discussing, right? You just have to remember degree of freedom, and Cp is equals to 3R, Cv is equals to Fr by 2, right? That's it. That's it what you have to remember. After that, apply the formula for Cp. You can calculate that, right? What is gamma? That is Cp by Cv, right? Okay. So now this gamma is equals to Cp by Cv. This is 7 by 2. 7 by 2R, this is 5 by 2R. Just calculate, it will come out to be 1.4. Right? This is your 4R by 3R. This will come out to be 1.33. They can directly ask you what is the Poisson ratio for SO2 gas. We know that Poisson ratio is 1.33. Right? Okay? Understood this? Any problem here, students? Any problem here? Any problem here? Now, as you can see, you can also write one more thing, one more conclusion here, that the gamma of monatomic is greater than gamma of diatomic, is greater than gamma of triatomic. This also they can ask you, that which of the following thing is generally true, right? So this you can see, this is greater than, this is decreasing. Monatomic 1.6, this is 1.4, this is 1.3, right? Okay? Clearo, clearo? Yes? Yes, everybody? Right? That was a very simple thing, right? Very simple yet very important question. Now, in this case, what they have given, NEET 2012 question, equal volume of two monatomic gases, A and B, they are saying, at same temperature and pressure are mixed, the ratio of specific heats of this. Simple. Monatomic gases are mixed. So monatomic gases, what was the answer for gamma? Gamma was what? 1.66. So answer will be D. Right? Simple question. See? Simple. If you're not able to recall that, then you can obviously calculate that. Right? You can definitely calculate that. So answer will be D becomes your correct answer. Is it? Yes, students, D will become your correct answer. They have specified, they have calculated it, right? So we have already done the calculation there, right? Next is your adiabatic. Now here we will discuss about work, right? It's a very important concept. Let us discuss about work here, right? Let us discuss about work here. Chalo. Now, tell me, what is the first law of thermodynamics? Are you all ready for adiabatic processes? For adiabatic processes, I'll make it simple. Don't worry about that. Easy, ma'am, because of your explanation. Perfect, beta. Perfect. Chal. Now, are you guys ready for adiabatic process? Because this will need more attention, more concentration, right? I would say this is that question where students do mistakes, right? They are like, they are not able to understand only what exactly is happening, ma'am. We are not able to understand what exactly is happening here. What is the formula? So many formulas you have given us. How to answer that, right? So firstly, let us calculate the value of work here. Work, the formula of, okay, one very important thing I am saying here. The formula of work is same for reversible as well as irreversible. So what I am going to derive the formula of work that is applicable to reversible as well as to irreversible. But there are two formulas to calculation of T2. I'll tell you. Okay, firstly let us calculate the value of work. Now, delta U is equals to Q plus W. Is it? Delta U is equals to Q plus W. Now, can I say that for adiabatic process Q is equals to 0? So, I'll put Q is equals to 0 over here. Can I say Q is equals to 0, everybody? Q is equals to 0, right? So, delta U is equals to W of adiabatic, right? That means W of adiabatic is equals to delta U. Now, we have calculated the value of delta U. What was the value of delta U? Everybody in the chat box. we have calculated the value of delta U somewhere here. NCVM delta T. Should I put it there? Right? I'll just put the value over there. So that will be NCVM delta T. I'll just put the value here. NCVM delta T. I know in your books it is written NCV delta T. In the bracket they will mention, again I am saying, I am writing VM here. Why? Because I don't want you to get confused in that. Right? So this is for molar heat capacity. If you're cramming those formulas that I have written here in the notes, stick to that only. Don't be like, ma'am, in the book it was mentioned CV, so I thought you have written incorrectly. Right? That is CVM only. Right? Okay. So this is NCVM delta T, that is your W adiabatic. Right? Work of adiabatic. Now, tell me, what is the value of CVM? What is the value of delta T? Achha, from this, so you can calculate. This is your work. This is the value of work. Firstly, so let us write that this is your value of work. Achha, from here also I need to write one more thing here. That work adiabatic, just write it here. N CVM T2 minus T1. Now, see what they are going to give you in the question, okay? This is your formula of work. You don't want to remember anything, just remember. I don't like to cram these kind of formulas because this, so you can do two-step derivation it is. So you don't need to cram this formula, right? So easily you know that W adiabatic is equals to delta U, delta is equals to NCVM delta T. Why to cram this, right? So here understand one thing, that T1 will be given to you in the question, right? They will give you T1 in the question. CVM they will give you. Either they will give you this is a monatomic gas, you can easily calculate the value of CVM, or they will give you it is a diatomic gas, right? What is CVM? What is CVM? That is CV divided by N, no? CV divided by N. So you can easily calculate that, right? Next is number of moles will be given to in the question. What will not be given is this T2. This is where, this is the favorite kind of question from adiabatic. T2 will not be given to you. Is this question, there are two monatomic molecules, so why don't we want to, no, we will not do that. We will not do that, right? So directly we will calculate the value of gamma, two monatomic, for each of them gamma will be equals to that, right? For each, even if they give you 3 monatomic, 4 monatomic gases, right? They will not interact with each other, right? So monatomic gases, inert gases, they will not interact, so no multiplication, nothing, right? So directly gamma is 1, 2, 3, 4, any they give you, gamma is equals to that, right? Now you have to understand that how to calculate this T2 is the main task. Understand what is the problem here? They will give you the value of N, they will give you CVM, they will give you T1, they will not give you T2. The task is to calculate the value of T2, final temperature. Either so they will give you question where it will be find the final temperature here, or they will give you usually they give you only find the final temperature, right? So we have to understand how to find the final temperature, right? So this is for reversible process, I am finding out the final temperature, right? Okay, so here the answer was CVM. This is going to write it here, or should I just write down the formula here? Because derivation, why to do the derivation, hai na? Just write down the formula. Firstly for irreversible I will write, then for reversible, right? Firstly for irreversible I am writing the formula, directly I am writing the formula here, right? Where is irreversible, where is reversible? I am directly writing the formula, okay guys? Because derivation is very long, that's not important for you, right? So I am directly writing the formula here. That will come from this side only. We know that W is equals to minus P. If you're not able to derive that, so you can just understand this thing, delta V equals to NCVM T2 minus T1, right? Okay, so this is your, if I write it there, this is basically V2 minus V1 This is nothing but V2 minus V1. I know what is the value of V2. V2 is equals to nR T1 by P2. nR T2 by P2, right? So this will be minus P external. V2 is what? nR T2 by P2 minus nR T1 by P1, right? So from here, this is NCVM T2 minus T1, right? Okay. So how you will take it? This is your P external. I am writing the final equation here, right? I am writing the final equation here. N CVM delta T equals to minus P external nR 1 by nR T2 by P2 minus T1 by P1. Right, this will become your final answer. Right, so now see one thing. Here also you can write this T2 minus T1. So basically what you will do, if they have given you irreversible process, they have given you irreversible process. Irreversible process means that is at one step. They have anywhere written one step, or they have written anywhere constant external pressure. Constant external pressure. Right? They have written constant external pressure. Any of these things that you see, then if you don't want to do like this, just simply, because this derivation is so very simple, right? But the derivation for reversible is kind of like tough, right? So this is totally your choice if you want to cram this thing or you want to derive. That's totally your choice, because it is an extended version of this thing only. I have just put one thing here. I have just put the value of W is equals to minus P external delta T, right? Minus P external delta V. Then I have put the value of V over here from ideal gas equation. Then I will get this particular thing. Now, in the exam, they will give you P2, they will give you P1, they will give you P external, they will give you number of moles, R you can put, right? N will be given to you, CVM will be given to you, T1 already given to you. You have to calculate the value of T2 from here, right? This is the formula to calculate the value, not work. Find T2 or final temperature from this formula. For irreversible process, you have to apply this, right? You will find the value of T2 here. Then this T2 you will put in this equation, right? And hence you will have your work of adiabatic. Understood this or not? Right? Understood or not, students? See, this is your adiabatic process. If adiabatic process is mentioned in the exam, then how you will calculate? Either the first thing is they will just ask you directly calculate the final temperature. If it is a reversible process, everything will be given to you. Just have to calculate the value of T2, right? You just have to calculate the value of T2. Tell me, is that clear or not? Is this thing clear or not to everybody here? Is this thing clear or not to everybody here, right? Okay. Now, for reversible, this was a whole irreversible, no? Have I deleted that page of reversible? Yeah, I have deleted that page. No issues. Now, let us see for adiabatic reversible. Find final temperature for adiabatic reversible. Adiabatic reversible. I am feeling so small. Okay, so this is your find final temperature for adiabatic reversible, right? So now, this is simple. You don't have to derive anything. PV gamma is equals to constant. Usually you will not use this. PV gamma minus 1 is equals to constant. Gamma is that CP by CV, right? Or you can have P1 minus gamma, T gamma is equals to constant. See, basically what you will do here, Beta, am I audible? Am I audible? I just did something with this one. Am I audible? Audible, right? So this PV gamma is nothing but P1 V1 gamma is equals to P2 V2 gamma, right? Usually you will use these two things, right? Because it includes temperature. Mostly they will give you T V gamma minus 1. In the question, most probably they will give you this thing only, right? If they want to make it difficult, they can give you this thing. This though they will not give you, right? So usually we will use this thing only, that is your T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. I am just giving you one example that in the question they have given you this is a monatomic gas. For a monatomic gas, what you will do? For a monatomic gas, simply what you will say, this is a monatomic gas. So gamma is equals to 1.6. You will put the value of gamma, right? You will simplify this equation and then you will calculate the value of T2 from this side, right? You will calculate the value of T2 from this side, right? Here also, what they will give you, this is P1, 1 minus gamma, T1, this is gamma, this is P2, 1 minus gamma, T2, this is gamma. Here again you will calculate the value of gamma. But most probably they will give you this thing. Like I can guarantee that they will give you volume V1 and V2 and from that you will calculate the value of T2 because this will become little twisted for you, right? Okay, because the mathematical concepts will be more involved, right? So it will usually what I have seen in thermodynamics, they will give you this thing only, right? Okay, understood? Okay, students, right? I think free expansion. Okay, so we will also do some questions based on that. Next is your free expansion. Next is your free expansion. Baswa sir is there. He's like, are you live, ma'am? Yes, I am live. Teaching them thermodynamics.
Thermodynamics.
Yeah. So, next is your free expansion. Sir, tell me what will happen in free expansion. Any idea about
It
it?
will expand freely.
Huh. Very good.
Correct.
Huh.
Okay, expression, free expand.
Expansion.
Okay, expansion.
So, what will be the work done in free expansion?
No, zero.
Really, how? How the work done is zero?
Free expansion.
Hmm.
Work done by the system.
Do you remember all of these things?
Yeah, a little bit.
Wow, yeah, I'm so impressed.
Huh?
Yeah, I'm really impressed. Tell us. Free expansion, how you said that work done is equals to
No, I
zero?
remember it's from the memory.
That's from the memory.
Yeah,
Oh my
yeah.
God, who was your chemistry teacher?
No, I remember usually like once I remember something, right, for a very long time, like it is stuck in my head.
That's why you're a bio teacher.
Yeah, exactly.
That's why, because you are able to remember. So yes, Baswa sir is right. Work done is equals to 0 and heat change is also equals to 0 because it is expanding freely. There is no boundary, nothing is there, right? So from first law of thermodynamics, Q plus W both are 0. So internal energy is also equal to 0. So in free expansion, they say that all the terms involved in first law of thermodynamics, delta U, Q, W, all will become 0.
Zero.
Because work is 0, it is expanding freely. It is like, for example, some paper has leaked. So do they have to do any work? Everything is expanding
Expanding
freely.
nothing I have to do.
So, not work done is 0.
Zero. So yeah. Now how are they doing, ma'am?
Yeah, they are doing good. Abhi to the students are really gone because you know they very less students will stay there till the end.
Yeah, they are very.
Yeah. They're like, ma'am, we want to complete thermodynamics.
But
It's a tough chapter.
Huh.
But ma'am, can you complete it within like half an hour or 1 hour? Every concept should be in detail, ma'am. From that 1 hour only, they want all the questions. But they won't stay there for long. That's the problem. That's the problem of these kids.
Yeah.
But some of them will stay there till the end of the chapter.
I've seen some of them stay till the very end.
Till the very end. And some of them just after some time, they'll be like, oh, I'm like
done,
dead
I'm done.
tired.
When you finish, ma'am, I'll be outside waiting.
Yeah. I'm almost about to finish only. Okay, bye-bye, sir. So, yes. Okay. So, that was your free expansion. Now let us talk about some questions here. The question is NEET 2020 question, okay. So the question says that the correct option for free expansion of an ideal gas under adiabatic condition. Free expansion under adiabatic condition, that means Q is equals to 0. Right, for free expansion work is equals to 0 as sir has told, right. So delta U will also be equals to 0, right. If delta U is equals to 0, delta T will also be equals to 0, because why? When internal energy is 0, when temperature is constant, right. So this is 0, this is 0, this is 0, all of them are 0. So answer A will be the correct answer, is it? Yes, A will be the correct answer, right. Okay, A will be the correct answer. Now, next is as I told you that 2003 question, that they can ask you this thing, from your, if some chemical equation is given to you, right, then you have to use the formula of delta H is equals to delta U plus delta NGRT. Right, so that means delta H minus delta U becomes delta NGRT, right. Achha, what is delta NG? Everybody in the chat box, what is this delta NG? Now this is your liquid, so it is not under gaseous. This is your gaseous, this is gaseous, and this is also gaseous. So delta NG will become, what is that? This will become 3 minus 6, right, because in the reactant side it is 6. So it is minus 3. So this will become minus 3 RT. So answer will be B will become your correct answer. B for Baswasar, right? That is your correct answer. Is it? That is your correct answer. Everybody in the chat box, is that clear? Everybody in the chat box, is that clear or not? Now, what is the limitation of first law of thermodynamics? Let us see. It does not provide any information on the direction of flow, right? No information on the direction of flow is given to you. Heat is unidirectional in nature, moves from hotter region to cooler region. It says that it always, but there are some opposite things also that happens in our life, right? Then it says that certain naturally occurring reactions happen spontaneously and unidirectionally, right? So we always say that the reaction that are naturally occurring, they are usually non-spontaneous, right? But some of them are also spontaneous, so they are basically the limitations of your first law of thermodynamics. Now let us talk about the spontaneous process. What are the spontaneous processes? Spontaneous processes are those processes that are occurring like naturally, right? You don't need any external thing for that to occur, right? For example, some of the students, they don't need any external motivation for them to study, right? They are internally motivated to study. They are spontaneous processes, right? A reaction happening on its own or without any trigger is called spontaneous. A spontaneous process is irreversible process, right? If something is happening on its own, it will never feel like, if you are studying because you want to study, then nobody can stop you, nobody can reverse you back, right? Then there is, for example, burning of gas in air. That is a spontaneous process, right? Dissolution, with some initiation, it will take place by itself. Dissolution of sugar in water. You add sugar in the water, it will itself get dissolved very easily. That is your spontaneous process. What are non-spontaneous processes? That need some external thing so that they can occur, right? A process which neither takes place by itself nor by any initiation, right? It needs something, needs some work to be done on them so that this reaction can happen, right? Flow of heat from cold body to hot body. From hot body to cold body, it is simple, that will be flow, right? There will be flow of, that is naturally that will occur. But when we talk about cold body to hot body, in that case, it is not a natural thing. It is a non-spontaneous thing, right? You will have to do something to make that happen, right? You will have to do something to make that happen. Now let us talk about entropy. Everybody in the chat box. Entropy, let us talk about entropy. Are you all ready for entropy? Let me see how many likes you have given me. let's make it 100, okay, by the end of this lecture. Chalo. Now, what is entropy? Entropy is nothing but it is randomness. For example, you are sitting there in the classroom. Now, you're very like in the classroom, teacher is present there. You are sitting like this. Okay, ma'am, we will study everything. You're sitting like that. But as soon as the teacher goes out of the class, you all students, you go crazy, right? You are just pulling each other leg. You're doing like, for example, you are kicking each other, slapping each other, and what not you guys are doing, right? Okay, because I used to do that, right? So now entropy means randomness, right? When the molecules are randomness, in the random motion they are going, right? So more is the randomness, more is the entropy, right? So here the formula of entropy is Q reversible by T. That is the formula of entropy, that is Q reversible by T, right? And yes, it is a state function and the units are calorie per Kelvin per mole, joule per Kelvin per mole, right? Next is, this is a these next 3 pages are very important because here I have written some theory questions for you, right? Very important it is. So see, first thing is which has more entropy, right? More is the randomness. Solid, the molecules are very at a very fixed position. They are not going here and there. They're just sitting there like you are in the classroom. So entropy is less. Then there is liquid, then there is gases. Liquids are slightly more away from each other. Gases are like, they are very, they are moving here and there. Now you have air in this room. It is very, it can expand itself to a very large container also, right? So basically the randomness is very high because molecules are very far away from each other. So that is why for solid, liquid and gases, this is the order of entropy. Next is at constant volume. If you talk about at constant volume, as temperature increases, entropy increases. If you talk about constant volume, right? If you increase the temperature at constant volume, right? Temperature increases, right? So what will happen? For example, I'll tell you, you're sitting somewhere, I'll tell you that there is fire in the building. What you will do? For example, you went to a mall. Someone tell you that there is fire in this mall. What you will do? You will just sit there. You'll just sit there. Okay, I don't care. I am fireproof. Something like that. Do you have those kind of, I would say, are you Spider-Man? Do you have those kind of energies? Do you that kind of power, strength? Do you have that? No, nah. You will run. You will like, I want to save my life. Right? This is what they are doing. As the temperature increases, entropy increases. Molecules will run. Right? Next is at constant temperature. If temperature is kept constant and you are increasing the volume, right? Increasing the volume, gases are moving away from each other. So entropy is again increasing. Randomness is increasing, right? Randomness is increasing. Now, for gaseous substances, more complexity in a substance, more bonds, molar mass lead to more entropy. More is the complexity, more is the entropy, right? That means more is the molar mass, more will be the entropy of that situation. See, if 2 students are sitting there, how much they can fight with each other? If 20 students are sitting there, they'll just eat my brain, right? So that's the same thing that is happening here. Next is very important regarding your delta Ng, how to predict. For example, some reaction is given to you. If a reaction is given, then how you will predict the entropy? If your delta Ng is positive, right? Number of gaseous moles of product minus reactant is positive, then you will say its entropy has increased. If your delta Ng is negative, then you will say entropy has decreased. Here entropy has increased, here entropy has decreased. If you say, because for example, earlier you have 2 and here you have 5. So your number of gaseous moles have increased. If number of gaseous moles have increased, earlier I had 2 students, then I have 5 students. 2 students will not eat my brain. That means 5 students will like, oh my god, they are fighting with each other. How to control them, right? So entropy will increase here. If earlier I had 5 students, now I'll have 2 students. That means the product has less gaseous moles, delta Ng is negative, entropy has decreased here, right? So for example, this is 0, then there is no change in the entropy. Entropy is same as it is, okay, right? Next is very important, temperature, pressure, volume. If you talk about temperature, as I told you, entropy will increase. If you talk about pressure, you're increasing the pressure, you're applying the pressure. So what you will do? The molecules are getting more close to each other, right? That is why you're increasing the pressure. Like, okay, you can't sit here, and some teachers are like that, na? You can't move your hand also. You can't go there and outside eat something. You can eat, so let's forget. So some teachers also say that, okay, you can't go to washroom. Why? Because you have to control. You can't go, right? There is no nature's call. Oh my God, how, like, that was the most non-spontaneous thing that a person can say, right? That means that's a natural thing, right? How can you stop a kid from that? So this is your entropy, because you are making the students in a very rigid mode. You're increasing the pressure. Molecules are very close to, earlier the molecules were like this, now the molecules are like this, right? So that is why randomness will decrease, entropy will decrease. If you're increasing the volume, earlier the volume was this, now you have increased the volume, the molecules have more space to move, to go. In the classroom, you have less space, so you are sitting like that. But when in the playground, you have your games period. So what you do? You have a big ground, you will move here and there, you will relax, chill, right? So here, volume has increased, so entropy will increase, right? Okay. Now next are some examples here. Right, next are some examples here, very important examples. From these examples as well, directly the question can be asked. One is your graphite is greater than diamond. That means entropy we are talking about, the entropy of graphite. Graphite, basically, if graphite has free electron also, it has van der Waals forces, it has layered structure. That is why the between those layers, it has van der Waals forces. That is why the entropy of graphite is more. But diamond has a very rigid network like structure. That is why its entropy is less as compared to graphite. So that is the first question that can be asked, right? Second is precipitate formation. If you talk about the precipitate formation, for example, you are doing some reaction and there is formation of this precipitate. For example, AgCl is formed, precipitate has formed. This arrow is for precipitate. We know that precipitate is a solid thing. So something has converted from maybe liquid to the solid state, right? So that means the entropy has decreased here. So you will write entropy has decreased. Dissolution. Dissolution means, for example, you have added something, it is getting dissolved. For example, you have NH4Cl, it is getting dissolved in water in aqueous medium. This will get split into ions. Earlier you had 1 mole, now you have 2 mole. Basically what has happened? Your number of moles, number of molecules has increased, right? Okay. Okay, Satish, don't worry, I will see that, okay? Don't worry about that, okay? Don't worry about that. We will focus on that. So this is your 1 mole, this is your 2 mole. That means your entropy has increased because number of molecules has increased. Rusting of iron, right? When you have iron, there is rust over it, then entropy increases because of the water of crystallization that is attached over there. That is why the entropy will increase in the rusting. Boiling of egg and stretching of rubber band are very, very important. Boiling of egg because of the denaturation of protein. Usually, students think that, ma'am, when you have egg, right? Okay, egg is in the liquid state, right? When it is not boiled, right? So the inner material of egg, right? So when you boil it, that becomes solid. So what do you think that, okay ma'am, that liquid has been converted to solid. So entropy should decrease. But in bio, Gopika ma'am, Baswa sir must have taught you about denaturation of protein. Right? So because of the denaturation of protein, its secondary, its structure basically splits up, right? So basically because of the denaturation of protein, the entropy increases. You can write here denaturation of protein, of protein, of protein, right? Next is your stretching of rubber band. Now, for example, I have a rubber band. Do I have it? Yes, I have one rubber band. Wait a minute. So, for example, I am talking about this rubber band, right? So, I am stretching this rubber band. I am stretching this rubber band. So, according to you, what should have happened? Ma'am, you are stretching the rubber band, right? So, ma'am, there must be that number of molecules are now away from each other. The randomness should increase, right? But actually, because of the alignment of molecules, wait a minute, because of the alignment of molecules, that is why I am saying these two are important, because earlier they were random, right? Earlier what happened, it was a randomly they were here and there, but now when I stretched it, now they are aligned properly in a straight line, right? Because of that is the reason the entropy will decrease here, right? So you will say entropy will decrease here, right? Okay, students. So there is one more thing regarding entropy that can be asked to you, right? That is the formula of entropy, right? I am writing it here. Okay, I am writing it here. Delta S is equals to NCVM, natural log of T2 by T1, plus this is R, this is yes, R, NR. Right, this is NR, natural log of V2 by V1, right? And this is your delta S equals to NCPM, natural log of T2 by T1, plus NR, this is your, in terms of pressure I am writing here, this will be P1 by P2, right? You just have to remember these two equations, that's it. Okay, you just have to remember these two equations I am writing here. These two equations are for irreversible adiabatic process. Acha, I'll tell you one thing here, they will not ask you any, they will just directly ask you the formula, right? They will not ask you any numerical from here, right? So most probably they will ask you directly the formula only. So adiabatic process, irreversible adiabatic process it is. Understood? Irreversible adiabatic process, you can either apply this or this, and trust me, you don't have to remember any other formula for entropy. From this formula only we will generate all the other formulas, right? All the other formulas from this formula only. Now if I talk about for reversible adiabatic, for reversible adiabatic, can you tell me what can be the answer? Adiabatic. For reversible adiabatic, we know that delta S is equals to Q reversible by delta T, right? Isn't Q reversible is equals to 0? Because it is adiabatic. Adiabatic means Q is equals to 0. And it is for reversible, for Q reversible is equals to 0. And in the question, it is Q reversible only. So, it will become equals to 0. So, for reversible adiabatic, entropy is 0. For irreversible adiabatic, these two formulas you can apply. Okay, for irreversible adiabatic, these two formulas you can apply. Now, tell me, is there any problem regarding these two equations? Is there any problem regarding these two? For reversible, it is Q reversible 0. For irreversible adiabatic, you have to apply these two formulas, right? Okay. Now, ma'am, the next question is, what about isothermal? If they talk about for isothermal, I'll just put the same thing in both the cases. For isothermal, T2 is equals to T1 because there is no change. So if T2 is equals to T1, T2 is equals to T1 in these two equations. So this will be cancelled out. Now natural log of 1 is 0. This will be T2 by T2. That means natural log of 1. Natural log of 1 is nothing but it is 0 only. So delta S will become, delta S will be equals to, this whole will be 0, this will be 0. So that will be equals to NR natural log of V2 by V1 or equals to NR natural log of P1 by P2. Right? Okay? Anything can be the answer. Right? Okay, students? Right? Achha. Now tell me one thing. If you talk about for adiabatic we have done, for isobaric situation, that means P1 is equals to P2. Right? So here I will use this formula. P1 is equals to P2. Oh, why I have written directly P2? This will be natural log. Wait. This will be natural log of P1 by P2. Okay. Yes. So now, if I am saying that P1 is equals to P2, that means natural log of 1. And natural log of 1 is equals to 0. Write it somewhere. Natural log of 1 is equals to 0. Right. So if this is equals to 0, can I write here that delta S is equals to this thing, that is NCPM, because this whole will become 0. So this is NCPM, natural log of T2 by T1. Natural log of T2 by T1. Right? Okay, last one is for isochoric. Everybody in the chat box, tell me what is the condition for isochoric. What is the condition for isochoric? What is constant in the isochoric process? Volume is constant. So can I say V2 is equals to V1? So if V2 is equals to V1, if I put the V2 is equals to V1 here, then natural log of 1 becomes 0. So here the answer will be this thing. That is NCVM. You can write delta is equals to NCVM natural log of T2 by T1. So you just have to remember these two equations. You don't have to remember all the equations here, right? Just remember these two equations. You can derive anything out of it, right? You can derive anything out of it. Students, tell me any problem here, any problem. We are about to end this chapter. Just few things are remaining because Gibbs-Helmholtz equation also is repeatedly asked to you, right? So let us jump to the next thing. Tell me beta, any problem till here? If so, then let me know in the chat box. If there's any problem, then let me know in the chat box. Okay. I think, yeah. Okay. Right? Okay. Now, you have second law of thermodynamics, right? Second law of thermodynamics. Not a very important statement. You just have to remember that enthalpy of this universe is constantly increasing. Entropy of this universe is constantly increasing, right? So you just can go through these three statements. First statement says that it is impossible for heat to move by itself from low temperature to high temperature body. Not very acceptable statement. No process is possible in which sole result is the absorption of heat from a reservoir and its complete conversion into work. Third is, this is the most acceptable statement, that all spontaneous processes or naturally occurring processes are thermodynamically irreversible, right? And for that process, entropy is constantly increasing for this universe, right? Okay, without the help of an external agency, a spontaneous process cannot be reversed, right? So here, what they are saying, when a system, this is the second law of thermodynamics, by different statement, you don't have to remember that, just remember this thing. When a system is in equilibrium, the entropy is at maximum and the change of the entropy is 0. We can say that entropy of a spontaneous process increases till it reaches its maximum, and at equilibrium the change in entropy is 0. Basically they are saying that entropy of this universe is constantly increasing, right? Entropy of this universe is constant. This is, I am talking about universe is constantly increasing, It will reach to 0 at equilibrium, right? At equilibrium, it will reach to 0, right? So here, when you talk about, because second law is talking about spontaneous processes, there the entropy of this universe is greater than 0. When you talk about non-spontaneous processes, the entropy of the universe is less than 0, right? So basically just remember 2-3 things here. For a spontaneous process, I am writing delta S is greater than 0, delta G is less than 0. These are two very important conditions, that delta S is greater than 0 and your delta G is less than 0. Okay, these are the two very important conditions. Delta G is Gibbs free energy. We will do it in the next part. Okay, delta G is Gibbs free energy. Let's see Gibbs free energy. So now for Gibbs free energy is basically the amount that is converted into useful work. For example, if you are sitting here and you are doing something, you are doing the useful work. So that is your useful work, right? So you can say that your delta G is nothing but this is the useful work that you are doing, right? And this is a very important equation that is called Gibbs-Helmholtz equation. From here also the questions are asked, right? Delta G is equals to delta H minus T delta S. Very, very important equation, because this will tell us the criteria of spontaneity, right? Why? What kind of questions are asked here? The criteria of spontaneity. You can see this in your PYQs from the past 5 years. So repeatedly they are asking this question, criteria of spontaneity. Spontaneity, right? They will ask you which equation, at what condition this will be spontaneous, right? So let us talk. We will answer this according to, with the help of the Gibbs-Helmholtz equation only. Now let us see this table. Very important table. See, this is written here, delta G is equals to delta H minus T delta S. Now understand it very carefully. Okay. If I am saying my delta H is negative, that means the energy is released. If I am saying this is negative and I am saying T delta S is positive, this will be given to in the question, right? If this is negative, this is positive, right? This is positive. So this is negative, this whole term will become negative. So answer will be delta G will be negative, no matter what is the magnitude of delta H or T delta S, the whole term will always come to be negative only. And when delta G is negative, then can we say that it is actually a spontaneous process, right? So it is actually a spontaneous process, right? Okay. Spontaneity is always determined with the help of delta G, not delta S, because delta S we are talking about this universe. Delta G generally we are talking about whether it's universe or system. It is always, if delta G is negative, it is spontaneous, right? That's why we are calculating delta G here. Not on the basis of this I am telling, I am basing on the basis of delta G I am telling whether this is spontaneous or non-spontaneous. This was your first case. Second case is when you say your delta H is positive. If your delta H is positive, I say, if I am writing it here, that this is positive, right? And your T delta S is negative. If this becomes negative, so this negative will become positive, so whole term will become positive, isn't it? Whole term, because negative will become positive, whole term will become positive. So always it will be a non-spontaneous process, because always delta G is positive here. Always your delta G is positive here, right? Okay. Third is your when delta H is negative. Delta H they are saying it is negative. But your T delta S is also negative. This is also negative, right? So can I say that here it will become negative plus positive. Now, if I have to make it spontaneous, my delta H value, my negative value should be greater. That means it is spontaneous only when delta H is greater than T delta S, right? Okay. It is spontaneous only when delta H is greater than T delta S. Okay, so this is the fourth condition that I am writing here. The fourth condition, everybody, The fourth, this is a very, very important table, okay? This is a very, very important table. Fourth condition is when this is your positive. When it is positive, I am writing it here. When this will be your positive thing, this is your positive. And this is, they have written this is also positive. So it will be positive minus positive. I know to make it negative, I know this term should be greater only, then this whole term will be negative. So my T delta H should be greater than delta H, only then it will be a spontaneous reaction, right? Okay, students, understood this or not? It's actually the criteria of spontaneity based on Gibbs-Helmholtz equation, right? It is based on Gibbs-Helmholtz equation. Is that clear to everybody or not? Is that clear or not? Is that clear or not, everybody in the chat box? Now, the question that is given is NEET 2020. I told you, right? So, in the last some years, this has become a very important question, right? So, for a reaction, this reaction is given to you. The correct option is, now they are saying for this reaction, the correct option is. Firstly, so you have to understand one thing. You are dissociating. Two molecules are not dissociating. They are combining to form Cl2, right? If you dissociate, if you break the bond, then energy will be required. Here the energy will be released, right? If delta H is negative, and because it is from two molecules to one molecule, so entropy is definitely decreasing. Entropy is decreasing. Why entropy is decreasing? Because number of moles are decreased, right? So this is also less than 0, this is also less than 0. I feel D should be the correct answer, right? Okay. Okay, students. Not B, not B. Why? Because here energy will be released. Why the energy is released? Because if you have one molecule of Cl2, you are breaking it, then you will require the energy. If two atoms are joining to form a gas, then they will release, they will be happy that we are becoming gas, right? So they will release the energy. So energy will be released here, right? So that is why this is negative, this is entropy is negative, because number of moles are decreasing, right? Okay. Next is, okay, 2017 for a given reaction, right? So this is basically based on Gibbs-Helmholtz equation, 2017 question. It says that for a given reaction, delta H is this much and delta S is this much. The reaction is spontaneous. Assume that delta H and delta do not vary with temperature. So the reaction is spontaneous, right? So if you talk about delta G will be less than 0. What is delta G? Delta G is delta H minus T delta S is less than 0. So if you take out it there, so you say delta H is less than T delta S. That means, can you say that temperature is greater than delta H by delta S? Now what is delta H? Delta H is 35.5 kilojoule. And what is this? This is kilojoule, right? This is in kilojoule, right? Kilojoule. Kilojoule to joule you have to convert, right? So here it is, I can't see it only, 83.6. 83.6. This is in kilojoule, this is in joule. First you have to convert it into both into joules, and then you divide it, you will get your answer. Okay? Then you divide it, you will get your answer. So calculation, we can do it, hai na, afterwards also. So what you have to do, convert it into joules, and this is also in joules. This will become approximately 424.6, which is approximately equal to which option? Which is approximately near to this option. So it is greater than 425 Kelvin. Okay. Okay, students, understood this or not? Right? Okay. So these kind of questions can be asked. Right? Okay. Now last is your third law of thermodynamics. Very simple law. The entropy of perfectly crystalline solid. Firstly, there is no perfectly crystalline solid only. That's why no entropy is equals to at absolute 0. The entropy is not 0. right? But here they are saying the entropy of perfectly crystalline solid may be taken as 0 at an absolute 0 of the temperature. This is a perfectly crystalline solid where no molecule is vibrating, nothing is happening. Perfectly crystalline solid, but in actual reality, there is no thing as perfectly crystalline solid, right? No solid is perfectly crystalline, right? Like there is no ideal gas, no? In the same way, there is no perfectly crystalline solid. So here, but the law states that for a perfectly crystalline solid, at 0 Kelvin, absolute 0, entropy is equals to 0, right? So what they can ask you, they can either ask you directly the the statement only, right? So the entropy of a perfectly may be taken as 0 at absolute 0. It helps in calculation of absolute entropy, right? So at absolute entropy you can calculate from here. Now what are the exceptions here that does not fit here? Even if you have perfectly crystalline solid of CO2, CO, N2O, NO, ice, isotropic form, etc. Here even at absolute, even for a perfectly crystalline solid, the entropy is not equals to 0. These are the exceptions that they can ask you, right? Very rare chances, right? Okay. This is so beta nothing, but you just have to remember this thing, right? S is equals to Cp ln T, that is 2.303 Cp log of T. That's it. This is your absolute value. Just remember this. If they ask you, just remember this equation. Other things you don't need to remember, right? Okay. Now, if you talk about fusion, in that case, you will use delta H of fusion, right? If you talk about vaporization, in that case, you will use delta H of vaporization. If you talk about here also, acha, see one thing, we know that delta S is equals to Q by T, right? So if you talk about at constant pressure, it will be equals to Qp by T, that is your delta H by T, right? At constant volume, it will be equals to Qv by T, that is your delta U by T, right? So when you talk about fusion, that will be delta H of fusion by T, right? Fusion means melting point will be there, okay? This will be your melting point. If you talk about fusion in terms of delta U, that will be delta U of fusion by T. T is a melting point. Here T is the boiling point because this is vaporization is happening. It is boiling, right? So it is delta H of vaporization by T. This is delta U of vaporization by T. Okay. Now, next is your thermodynamics. I am going to finish thermodynamics in 10 to 20 minutes, right? I will tell you what kind of questions they can ask you. Okay. Okay, students, everybody in the chat box, are you all ready for thermodynamics or not? Thermochemistry, sorry. Okay, I'll just give you one very, I would say, mantra of doing thermochemistry. Very simple, direct thing that will be asked to you in the questions, right? You can see the question, what kind of questions are asked to you, right? Firstly, though, you need to understand the definition that are involved. For example, I am talking about any thermochemical process. So in that different types of energies are released. There is heat of formation. What is heat of formation? When your compound, 1 mole of compound is formed from the reactants that are in the standard state. That is heat of formation. That is important for you, right? So for example, I am saying that here this thing that is released will tell us the heat of formation. Why? Because 1 mole of compound is formed from the elementary standard states. This is the elementary standard state. Oxygen exists as O2, hydrogen exists as H2. So from the elementary standard state, 1 mole of that compound is formed. So that is your heat of formation only, right? Heat of reaction is a general term, right? There are different types of heat of reaction. Heat of reaction is nothing but it is delta H only, right? Heat of reaction is nothing, it is delta H only. It can be positive or it can be negative. Positive means it is absorbing. Negative means the energy is being released. That is the heat of reaction. It is a general term. Now, if you talk about different types of heat of reactions, right? So, this is the simple, they are saying that when the heat is evolved, that means released, delta H will be negative. When heat is absorbed, then delta H will be positive here, right? So, if you talk about different things, for example, I am saying that you have the formation of quantities of reactants involved. So, you have the formation of this from the elementary state, right? So, 1 mole is formed. So, this will be your heat of formation. But here 2 mole is formed. So, this is not your heat of formation. In the first case, heat of formation is equals to heat of reaction. But in the second case, heat of formation is not equals to heat of reaction. That is the first thing. Understood? What is heat of formation? When 1 mole of the product is formed from the standard states, right? That is heat of formation. And for any reaction, energy is released or absorbed, that is heat of reaction, simple, right? So, here they are saying when you are doubling the reaction, heat of the reaction is doubled, right? Heat of the reaction like equilibrium constant, right? The same way. If you are doubling it, if you are multiplying it by 2, heat of reaction will also be multiplied. Here I am saying if there is change in the physical state, this is your water in liquid state, this is your water in gaseous state. I am not multiplying the stoichiometry coefficient here. That is why the heat of reaction is totally different. There is no link in the heat of reaction. There is no relation between these heats of reaction. Simple. Okay. When it is totally different, one is X, other is going Y. So, there is no relation between them. Here, I have made this equation from the first equation. That is why there was relation. Third is your allotropic form also. There is no relation, right? For example, this is your carbon diamond, right? Now, carbon dioxide has been generated from carbon diamond. Here, carbon dioxide has been generated from carbon graphite. Because different allotropic forms you have used, that is why it is totally different. Heat of the reaction has no relation with each other, right? So, heat of reaction different for different allotropic forms, right? Next is your condition for constant this and this. This you don't have to see, this also, right? Okay. Standard enthalpy of reaction, standard whenever you will see delta G naught, like this. Now, for any standard enthalpy, for anything that is standard, right, what you will write for anything that is standard, the enthalpy change accompanying the reaction when all the reactants and products are taken in the standard state. Standard state means solid, liquid and gas should be at 1 bar pressure. Substances dissolved in concentration should be of 1 molar concentration, molarity should be 1, right. Standard condition in thermodynamics does not specify any temperature. This is important, right. The temperature is usually taken as room temperature, that is 298 Kelvin. Usually it is taken as 298 Kelvin, but it does not specify any temperature. Standard condition do not have any specify temperature in thermodynamics. In thermodynamics, they don't have. Usually, if nothing is mentioned, you will take 298 Kelvin, right? Now, what are standard states? Standard states are, for example, carbon. The standard state is the graphite. The standard state of carbon is graphite. For sulfur, the standard state is rhombic sulfur. Different types of structures it has, and out of it rhombic is the standard state, right. Phosphorus, it is white phosphorus is the standard. This also they can ask you, right. This also they can ask you what are the standard states. Now, let us talk about heat of, let us talk about Hess's law, right. So, what is your Hess's law? In Hess's law, for example, this reactant is getting converted to product in this step. Here I am saying this is your first, this is your number 1 heat is released or absorbed. Now, other way that it is moving is from this to this is I am taking it as 2, from this to this I am taking it as 3, this to this I am taking it as 4. So, I know that in this case, the way I have drawn it, 1 will be equals to 2 plus 3 plus 4. So if you are changing one reactant to product, no matter what are the different path it is following, the total energy of one path will be equal to the total energy of other path, right? So can take place in a number of ways in several steps. The total enthalpy change is always same. It is independent of the intermediate steps that are involved. That is your Hess's law. This is also used, right? For example, you have this question, right? See this? This is the application of Hess's law, right? This is also important. For example, they are saying this is the required equation, right? And you are given with, I think this is your PYQ only. This is your PYQ, I feel, right? So they have given you 3 equations here. Now I want to have this equation, that is carbon of solid, carbon plus 2s. So I will multiply this by 2. I will multiply this by 2. Then I want to have CS2 in the end, right? Then I will subtract third. So for example, this is my first equation, this is my second equation, this is my third equation, right? So what I will do, I will add 1 plus 2 is multiplied by 2 minus 3. I will get this delta HF. You know why here they have written delta HF? Because 1 mole of this compound has been formed by standard states. 1 mole of this compound you are making from the standard state. Sulfur in its standard state, carbon in its standard state, right? So that is why here it is written delta HF. That is why delta HF is written here. So just do this thing, you will get your answer, right? What you're adding 1 and 4, subtracting equation 3. What you will get here, it is minus 393.3. 2 into this thing, that is 587.44. Now you have subtracted which thing here? Subtracted this thing here, that is minus plus 1108.76, and this will become your correct answer. Tell me students, any problem here? Any problem here students? Any problem here? Right? This is how you will apply Hess's law. Tell me any problem here. What you have to do here, they will give you one equation that you have to find out. They will give you 3-4 equation, the hints for that. By adding, subtracting, multiplication, you have to get to this equation, right? And this is only Hess's law. Whether you convert carbon plus 2s directly or you go through these steps, the answer will be same only. Right? The answer will be same only. Tell me students, is there any problem in that? Because this is a very, very important question. Right? Okay. Everybody in the chat box, tell me, is there any problem here? Now next is your heat enthalpy of neutralization. In enthalpy of neutralization, a very simple thing you have to do here. Right? Enthalpy of neutralization means we are talking about strong acid and strong base. Strong acid and strong base. What is neutralization? When there is acid and base, they form water plus salt. That is neutralization, right? So when you have strong acid, this is asked to you, right? So when you have strong acid and strong base, in that case, the heat that is released is minus 57.1 kilojoule per mole or 13.7 kilocalorie per mole, right? Kilocalorie, very, very important point. Kilocalorie per mole, right? So that is your very important question. If you have strong acid and strong base, then what is the amount of energy that is released? That is equivalent to this thing, right? Now, if one of them is weak, if you have weak acid and strong base, you have weak base and strong acid, right? Anything you have. If one of them is weak, then your enthalpy of neutralization will be less than the given amount here, right? For strong acid, strong base, the neutralization is fixed. That is minus 13.7 or minus 15.1. This is in kilojoule per mole. This is in kilocalorie per mole. For any other combination of acid and base, it's strong acid, it's weak acid, strong base, strong acid, weak base, it's weak acid, weak base, any combination, heat is less than that. Very, very important. Strong acid, weak acid, we have already studied that in ionic equilibrium, that for example they are giving you that for the formation of NH4CN. I know that this has been formed by a weak acid and a weak base. NH4OH and HCN, both are weak acid and weak base. So enthalpy of neutralization is less than minus 13.6 or minus 57.1, right? Okay, understood? So these kind of question can be asked. Next is your bond enthalpy. Now I'll tell you very simple thing, right? Very simple thing. For example, it's a conclusion, right? For example, they are asking you to calculate any heat of reaction, in heat of formation, heat of combustion, anything they are asking you. But hint is bond enthalpy, bond energy. Hint is bond energy. Here hint is not bond energy. Anything except for bond energy. Anything except bond energy. Anything except bond energy. Right? What do you mean by that, ma'am? See, if they have given you hint, that means they have given you bond enthalpies of different reaction, and they're asking you anything else, that is bond energy. They're asking you maybe heat of formation, heat of combustion, heat of reaction, anything they're asking you. You will do reactant minus product. This will be reactant minus product. So this will be reactant minus product. For example, I am saying that you have anything except for bond energy. Here you will do product minus reactant, right? This is the best thing that you can ever get to solve these equations, right? So if anything else is given you in the question, they have given you enthalpy. I will do some 2-3 questions here, right? So if anything except for bond energy is given to you, then you will use product minus reactants, right? If they have given you bond energies of different reactants and product, then you will use reactant minus product. Now I'll show you how to apply this thing. This is the beta very simple. Enthalpy of fusion they have given you. The energy released when there is fusion, energy released when there is vaporization, energy released when there is sublimation, right? And this is energy released when there is dissolution. Energy enthalpy of dilution is amount of heat released or absorbed when solution diluted by adding water to it, right? Then you have there are different types of energies, right? You don't need to get into that, right? So enthalpy of formation, I have already told you, when 1 mole of compound is formed from the standard states, right? That is your enthalpy of formation, right? Okay, enthalpy of combustion is when your 1 mole of compound is getting into combustion, right? So release when 1 mole of substance undergo combustion. In enthalpy of formation, 1 mole of product is formed. In enthalpy of combustion, 1 mole of compound is undergoing combustion. That is the difference between enthalpy of combustion and enthalpy of formation. Usually they will ask you enthalpy of formation and combustion, right? Enthalpy of reaction is simple. There is one reaction, any enthalpy that is released is enthalpy of formation, enthalpy of reaction. Enthalpy of formation can be enthalpy of reaction. Enthalpy of combustion is also enthalpy of reaction. Okay. So next is this one. Wait a minute. I'll see if there is some question regarding this. Currently, though, I can't see any question regarding this, right? For that, let's see. I'll just do one numerical here. Okay, I'll just put one. I'll see if I can have some numerical here. Wait a minute. One more question you can write here. Delta G equals to delta G naught plus RT ln QC, right? Plus R ln QC, plus R ln QC. Now, this is also very simple. At equilibrium, this also we have done in equilibrium, that's why I'm writing it again here. At equilibrium, delta G is equals to 0, right? So your delta G naught will become equals to minus R ln Kc, right? So if they ask you Gibbs free energy at equilibrium, you can just directly put this equation, right? Okay, now let me see if there is some question regarding, dekho. We have this question, right, regarding the enthalpy. 2-3 questions, I think after that the class is over. Now, the thing that I have told you here, I am going to solve one question based on that. So, see this. Change in enthalpy for the reaction. I told you any enthalpy they ask you, don't focus on that, right? You are given a reaction. If heat of formation is given to you. Achha, I told you one thing. If anything except for bond energy is given to you, then you will, what you will do? Product minus reactant. So, heat of formation of H2O2 is given to you, right? Heat of formation of H2O is given to you, right? And I have to use it here. Heat of formation of O2 will be nothing, 0, because O2 is in the standard state. It is existing like O2 only. So, there is no heat of formation of O2, right? In the standard state, there is no heat of formation, because in the standard state, they are existing like that only, right? Okay. So, you were born as an infant, right? So, there is no heat of formation when you were born. It was born as O2 only. Now, this will be product minus reactant. I know that delta H of that reaction will be product minus reactant. Product is what? H2O, right? I can write it the enthalpy of H2O square minus, into not square, this is 2 into H2O product minus 2 into H2O2. 2 into H2O2, product minus reactant, right? So, what is H2O? What is enthalpy for H2O? That is 2 into minus 286 minus of 2 into minus 188, and you will get your answer. It's very simple. It's very simple. What you have to do here? They are not asking you any enthalpy of formation. They are asking you, this is the reaction. Calculate the enthalpy of this reaction, right? Hint is given for if anything except heat, bond energy is given, you will do product minus reactant. So, here what I have done? Product minus reactant. Product minus reactant I will do, right? Okay. So, that will be your answer. First will be the correct answer. Now, dekho, second is this one. Here what they have given you? Here they have given you, on combustion, carbon form 2 oxides, right? On combustion, carbon is forming 2 oxides. One is it is forming CO, other is it is forming CO2, right? Heat of formation of CO2 is this one. If you have CO2, then he is saying that heat of formation of this is given to you minus 393.5, right? And that of CO is given to be delta H formation is equals to minus 110.5. Heat of combustion of CO. This is basically you have to get into this equation. Right, so firstly let's balance that out. This is your multiplied by half, right? So you want to have this kind of equation where it is half only, right? So what you can do? You want to eliminate carbon. If you subtract, this is your second equation, this is your second equation, this is your first equation. If you subtract 2 minus 1, this is all hit and trial only, right? So if you subtract 2 minus 1, it will be, this will be subtracted, so it will be, because it is CO2, right? If you subtract 2 minus 1, 2 is written as it is, right? It will form half O2, right? And this CO will be shifted to this side. You will have this equation that we require, right? So just do 2 minus 1, what you are thinking about, just do 2 minus 1. 2 is what your CO2 formation, CO2 formation. 2 is minus 393.5 minus 1. 1 is this, minus 110.5. You will get your answer, right? This is the thing that we require, okay? This is the thing that we require. So what will be the answer, everybody? What will be the answer? C will turn out to be the answer. You just have to subtract this from this, right? And you will have the answer as 283 kilojoule, right? Okay, so the answer will be 283 kilojoule because this minus minus will become plus, right? So the answer will be C. Okay, I'll see if I can give you one question based on bond energy, right? So that there is no confusion that is left. Wait a minute. Okay, I'm giving you one question based on bond energies, okay? Based on bond energies. No question regarding bond energy. I'm just giving you random ABC, right? So here, for example, you have a reaction. For example, you have a reaction. Let us say it is any reaction I can pick out here. This reaction I am taking, right? This reaction I am taking. For example, H2O2, H2O. Hi, sir.
Hello, ma'am.
Thermodynamics only I am
Oh,
teaching.
thermodynamics. Oh my god, that's why I came, ma'am.
Yeah.
I smelled thermodynamics. That's like.
But here we are doing thermochemistry.
Oh, is it? No.
I was like, I will complete thermodynamics, thermochemistry today itself. So can you please tell the students why in physics you have so different sign conventions?
Why in physics we have different sign conventions? That's because, it's not physics which has different sign conventions, it's chemistry which has different. So the
Oh,
question is on you, ma'am.
no.
Yes.
No, the question is
Are
not
we
on
heard?
me.
Okay.
Yeah,
Fine,
yeah.
fine, no problem. So that is the main thing.
I lower down your voice because of that.
Yeah. So you should ask chemistry, ma'am. Yeah, Diksha, ma'am, the question. Why it is like that in chemistry?
We are right only. Our scientists, I don't know what they were thinking. Why they were not in a good friendship zone. Why they
Yeah.
fought with each other. Like, okay, if you're going anti-clockwise, I will go clockwise.
So physics gives priority to on the system. Sorry, by the system. You give
For-
priority
for
to
me-
on the system.
For me,
Yeah.
by the system is logically it is right. Just if you have to do work, then you will be like feeling very negative, right?
Yeah.
So
I-
that yeah, he accepted that.
See, I will feel negative depends on who I have to work on. See, if it is like I have to sit and study some 100 books, then maybe I will be fully tense. But if I have to watch movie and all, then no problem.
That's not work.
Watching
That's
movies
the
work. You have
problem
to eat
with
popcorn.
physics. That's the problem. They have to complicate everything.
Yeah.
Why do you have to complicate that? If system is doing the work, system is sad. He is negative. If someone is doing the work for system, system is happy.
Who is the
Positive.
system?
System are students.
Oh my
If
God,
they
they are
have to
they are
work-
working next level. They are working next level. If I could have their brains right now, it would be I would be very happy because I can think only physics. You can think only
Yeah.
chemistry. They think physics, chemistry, biology,
Oh God, that's so
depression,
tough.
anxiety, exam pressure, parent pressure, school pressure, everything they can think of. Very good.
Yeah.
Cool.
But to have that, to make them less tensed, we
Yeah.
have one thing. What is that?
What is that, man? I don't know. Please tell.
We are taking one session, sir,
Okay.
today.
Yeah, today evening
It's
we
a
are
fun
taking.
session.
Okay, today evening, in fact, you know what problem? There is a small problem. I'll tell you. Earlier, we both planned a session, right?
Yeah.
Now, Gopika and Basu are also going to be a part of that session.
Oh,
Yeah,
nice.
we'll tell you the plan. So, guys, stay tuned. In the evening, we all four will come in a very interesting session. What is that session? You will get to know. In fact, it is like a surprise challenge for all the kids. We'll see whether you will be able to solve those many questions in that limited time. And they're fun questions, very different questions which you can't Google it also.
Nice.
Okay, so we'll meet you guys, okay? And we'll keep our topics similar. We'll keep those similar topics in physics and chemistry, and you will see Diksha ma'am and Shreyas sir fighting. That day you saw Baswa sir and Diksha ma'am
We
fighting.
were not even fighting.
Oh, I know, you guys were laughing. See, whenever Diksha ma'am is around, Nobody is fighting. Nobody is serious.
I don't
It's-
have that kind of aura, no.
No, ma'am, you are very serious while you are teaching. Only
Yes.
in front of us, Diksha ma'am will burst out laughing.
Yeah.
Okay.
So when I'm teaching, I'm fully like, yeah,
Yeah, she's a serious teacher.
A
Okay,
serious
continue,
teacher.
ma'am. All the best.
just 1 minute.
That's it. 1 minute worth of
One
teaching.
question, one
Oh,
question.
is it?
Just-
Okay, okay. All the best, ma'am.
Yeah. Okay. So the last question. For example, bond energies are given to you, right? So I am taking one example, that is H2O2. It is giving rise to 2H2 plus O2. This is the equation, that is, just I am giving you an example, right? For example, this is the question that is given to you, right? Now they are asking you the enthalpy of this reaction. They are asking the same thing. But here they have given you the bond energies. Bond energies means to break that bond. You have a break, you have a bond, you will break that bond. That is a bond energy that is required here. So in the question, if they have given the bond energy of H2O2, let it be A. Bond energy of H2O, let it be B. Bond energy of O2. Now, don't say that, ma'am, there will be no bond energy of O2. O2, we can break that. Now, that's a molecule. We can easily break that. What's the big deal? Right? So, we can easily break that. That is A, B and C. Now, see one thing here. That is A, B and C. For example, bond energy is A. Here, bond energy is B. Here, it is C. Now, your delta H of that reaction will be product minus reactants? No, it will be reactant minus products. So it will be bond energy of H2O2 multiplied by 2, because the stoichiometry is 2, minus of reactants, that is bond energy of H2O multiplied by 2 definitely, minus bond energy of O2. Right? So answer will be 2A minus 2B minus C. Now you understood what I was saying. Whatever they ask you, if they have given you any reaction, if they have given you bond energies, that will be reactant minus products. If they have given you for those compounds, they have given you any other thing, combustion, enthalpy of formation, usually they will give, right? Then you will say product minus reactants. Otherwise, you can definitely apply Hess's law also, right? For example, 2-3 reactions are given to you and you have to make one reaction. You have to calculate the bond energy of or heat of reaction of that one reaction. Then you will apply hit and trial method. That we have done one question here, right? Okay, students, that is clear. Is that clear? So, this is on combustion. Carbon forms 2 oxides. CO. This to we have done now. This to we have already done. Okay. Already completed. So guys, that's all for today. Finally, we have completed this big chapter, thermodynamics and thermochemistry. We have completed this. Now for physical chemistry, we are left with solutions, chemical kinetics and electrochemistry. So basically class 11th. Not even class, right? You are a NEET student, right? So, the chapters that were there in class 11th, we have completed that. Now, we are left with just 3 chapters and trust me on that, solutions, electrochemistry and chemical kinetics. So many questions are asked from this and these are actually simple chapters. In comparison to these chapters, they are simple, right? So, we will also complete physical chemistry in coming maybe 1 to 2 weeks. We will finish with physical chemistry. Inorganic chemistry we have already done. We are left with P block. We will start the NCERT line by line of P block soon, right? And organic chemistry also 3-4 chapters are left. We will do that. Don't worry. Okay. Okay then, bacha. Bye bye everybody and see you all in the next class. Do let me know in the comment section what is the next chapter that you want me to do, right? And there is one question for you. There is one question for you. That is, for example, what is the formula for, you have to tell me the formula for work done in isothermal, if I have written at constant external pressure, and I have written at variable external pressure. So I have not mentioned any reversible, irreversible thing here. You have to answer me what will be the formula where you will apply the formula of reversible, where you will apply the formula of irreversible, not in the chat box but in the comment section. I'll be waiting for your comments, right? Okay, then bye bye. Take care. See you all in the next class. Till then, keep smiling and keep spreading the love. Bye bye.